exactly 9090.
Mother's car is 9190. Hey, sorry, 9691.
9691.
My house number is 91.
You like the time?
Yeah, my father. This the shop number is 901.
Oh, 901. No wonder. Lucky number.
Feng shui for my dad, but not for me.
Yeah. Oh. How's your traffic yesterday? Okay.
I went to Seremban, reached around 3:30. That was terrible because after Melaka area, normally the jam will start out over there. For no reason, it will suddenly become jam. So, but I came back. Okay, I think I came back at 3:30 a.m.
But you are reaching quite late also.
Yeah, because I was driving slow. I was really tired. Coming back also, I think I stopped at Melaka Arena, lie down for a while, then I just lie down for 1 hour, 1.5 hours. And then drive to the area, then after that drive back slowly. So it's just one day we see only, so yeah. I thought I would just stay, book a hotel over there for one night, maybe. It's okay. Why need to spend so much on me? Let's see, but.
It's a project visit.
No, I just go there to visit my family member.
Follow your dad on programs.
Sorry?
I master with PLC.
I've gone to basic, key programming, yeah. But need to practice then only I will remember that again. Because last time when I was working for demanding, I focus on commissioning projects and everything. Then after that, in 2018, like that, I had to resign because of the boss helped me come back, and then I had to come back. Then I totally forget everything. I mainly now focus on marketing, digital marketing and everything. So yeah, I have to practice back then. My plan is I want to learn road rate with courses. Courses, that's another PLC under Big Brother. Big Brother come out with new PLC, Big Brother. But that PLC uses courses software. Courses is free. It's completely free. But yeah, PLC you have to pay, you have to buy it. Now if you buy it, you can use courses to program. You need to learn that. So yeah.
Same like computer, every time something to upgrade your software. You have to catch up.
Must practice. If you don't practice, then you end up like me, like everything.
I Okay, we focus analog.
Yes. Okay. So and digital. Okay. So far we learned digital, right? All these input output are digital. Digital means just on or off. Okay, it's a bit, right? We call bit or boolean. Okay. So for analog, if we have a range,
Boolean we haven't learned, right?
boolean is a bit.
Boolean is bit.
Yes.
BOL.
Yes. Okay. Boolean is all these push button, all these are boolean, or we call it as a bit, like one bit. Okay, it means it's on or off boolean. Okay. Analog means you will have a value, like a range. Okay. So for example, analog. Okay. What you can measure? Anything that you can measure. Okay. For example, like temperature. We have a value, right? Pressure, we have a value. Okay, temperature, pressure, what else? Gas, you want to measure the gas. Okay, you want to measure the humidity, you want to measure the flow, the water flow, right? Okay, or gas flow. You want to measure the, what else you can measure? Level, tank levels. Okay, so normally, you see, like analog, like digital, right? You have an input, you have a PNP or NPN. Means very simple, 0 volt or 24 volt. That is your input, right? So for analog, you will have a range. It means you can measure in voltage or ampere. Okay, voltage is like 0 to 10 volt. Okay, negative 10 to positive 10 volt, 2 to 10 volt, 1 to 5 volt. Means this is the range the device gives to the PLC. Okay, or 0 to 20 milliamp or 4 to 20 milliamp. Okay, these are the common industrial analog signals. Okay, for industrial. Okay. So how this one works? Okay. So when you have a CPU, right, your PLC, right? Okay, it come with the analog input module, right? Okay. The same thing. Okay, let's say for example, we have a CPU, then we have a digital input. Okay. So you see, you connect 0 volt or 24 and PN or PNP, right? So what is the function of digital input? It will convert this value into 0 or 1. Correct? When you give a 0 volt or 24 volt, in PLC I receive 0 or 1. Okay? Same thing for your analog input as well. Okay? So analog input, so you must have a transmitter. We call transmitter. Okay. Then you connect a temperature sensor, for example. Let's say this temperature sensor is 0 to 100 degree Celsius. Okay, 0 to 100 degree Celsius. Okay. Now, what is the function of transmitter? We will convert this value, this data, okay, into analog value. That is 0 to 10 volt or 4 to 20 milliamp. Okay, because these are the common. These two is the commonly used.
voltage.
Okay, for voltage 0 to 10 volt, for ampere 4 to 20 milliamp.
Okay.
Okay, then the function of our analog card, because the PLC cannot read these two values. Okay, so in the PLC, it depends on what type of PLC you are using. Okay, so for the CP1E, the range is 0 to 4000. Okay, 0 to 4000. Yes. Okay, so later we check in the manual the CP1L manual because we need to get the address as well. Okay, so 0 to 4000. Then what is what the programmer need to do is, because you see your device is, your instrument is measuring temperature, but in your PLC you get this value. Okay, so what the programmer need to do? Programmer need to convert back this value into temperature. Okay, so programmer need to do a scaling. It convert the analog input value, which is 0 to 4000 into temperature, which is 0 to 100.
Temperature and
AI value.
ampere,
AI value, analog input value. Which is 0 to 4000, convert to a temperature. Temperature, why? Because depend on what is my device, or what is my instrument I'm using. Okay. So we can do calculation here. So this linear scaling is what? Y equal to mx plus c, right? Linear scaling formula. Okay, then we can do calculation to get the y value. So this is your x value. We find out what is the m, what is the c, then we can get the temperature. Okay. And
so this is the format.
format is
AI analog. How is G4000 is coming from?
okay. This one you need to check the manual.
Okay.
In the manual. In the manual they will give you. Okay, so this manual, okay, for example, okay, they will tell you, okay, 0 to 10 volt is a 0 to 4000. If you're using the CJ series, is different. It's 0 to 12,000. If your Mitsubishi is different. Okay. So what you do? You go to Google. You look for CP1L EM CP1L-EM analog manual.
One day.
That's a model.
Yeah, 40.
Then that one don't. EM
40.
40 don't need. 40 can take out. There's a manual. Wait, here. This part. Okay. So you see, they say CIO area allocation. Okay. Can you see CIO area allocation? The channel allocation. Okay. This allocation is for the option port we are using. Okay. So our model is 40 IO. Correct. Our model is 40 IO. We have 2 ports, right? Okay. So if you're using the first port, the channel start with 2980.
Channel 2980.
80.
Okay. Can we out of 2980?
Yeah. This one is because additional, right? Okay. It's not until 29 because this model is still the channel is around 289.
289.
Normal lah, same like the CP one. Yes. Okay. But this is additional, right? So for additional, okay, they will they tell you that the additional option port you're using is start from 2980.
Oh, okay. The channel is a channel.
Yes, channel. Okay. Then for if you're using port 2 is a 2990.
Okay.
Okay. Now, what is the model we are using? The option port model. At this side you can see here. No, the option port. Diagram. And that side. Yeah. You can see the button. That's it. Okay. The model MAB 221, right?
CP
Okay. You see here. MAB 221. Okay. So it means I've got two analog input, 2 analog. Okay. So what is the address? Okay. What is the address? How to see the address? Okay. Now, so this is the address. Okay. But M means the channel lah. Can you see the beginning channel M? Okay. So you see. Now we are connected at the first port. Port 1 means it start with 2980 lah. Okay. So you have AI1, AI2, AO1, AO2. Okay, good. So AI1, what is the channel?
AI1 is M.
So M means is what?
Analog input 1.
No. M means is represent what actually? M is represent the channel. So it's a 2980. Yes, that's how you need to see. So 2980. So AI2 is a M plus 1, right?
Correct.
So it means 2981. So analog output is the M plus 5. So 2985, 2986. So these are the analog addresses. If you're using port number 2, it becomes 2990, 2991, 2995, 2996. Okay? Understand? Now, so this is the address, the channel. Okay? So for N, one channel, how many bits?
60.
16 bits. Good. Okay. Now, this is the analog, right? Analog means it's a value. Correct. Analog means it's a value. Value, right? Value. Okay. So if you want to use, we need to use the whole channel. We won't be using 2980.0.1.2. We won't do that. We will be using the whole channel, the whole 16 bit, like a D0, D1, all that, because we can keep value, right? So
because that one is only keep for one bit, one value, right?
what is that?
One integer, one binary, one.
Which one?
let's say for example check, let's say for example address is 0.01.
Yes.
This one which is for what?
Yes, it just give one bit value. If 0.01, 0.02, okay. If channel 0 means it will keep 16 bit
So
value.
that's why it's called boolean because it's only keep one.
Yes.
zero.
Yes. If channel 0, it means
16.
16 bit. Yes, this is the main thing. Okay. So later we will be using the whole channel. Okay, one channel. Okay. Now, can you see some auxiliary area here?
Okay.
Okay, you see that they say what they say is okay. If actually you can use these bits, you know, the LA area, these bits for to know whether the port is working normal or not. So you can get the data at this position, this area. So means A435.14 is for port 1. If the value is 1 means it's work normal. If the value is 0 means it's not some problem lah. So means you can use this bit to create memories. To create alarms.
Yeah. Okay. Because this 0.14 is only one bit.
Yes.
Okay.
Correct. So you see these are the functions of the A. Here got something. What is that? Okay, this one is output off bit, off effective, analog option for DA output clear. Okay, this one is to cut off your output, the analog output to clear the analog output value. You can use this analog output value. Yes. Okay, so for output lah. Okay. Yes. Okay. Now go down. Scroll down. Okay, here. So you see the analog input option board specification. They say 0 to 10 volt. It means you will get 0 to 4000.
0 to 15.
0 to 15 is the maximum lah. Okay, mean maximum that it can allow you to keep. More than that, it can spoil the cut. Okay. Then if a current, it means 0 to 20 milliamp, which is equal to 2000. So it means here. So 0 to 10, it will convert to 0 to 4000. 0 to 2000, it will convert to 0 to 20 milliamp, it will convert to 0 to 2000 in the PLC. So this is what we get. It is milliamp. Okay, you can see here. So if it is 0 to 10 volt, it means 0 to 4000. If 0 to 20 milliamp means it's 0 to 2000. This is the value I get in the PLC. Okay? Okay? Go down.
Interesting.
Analog interesting, yes. Good. Now you see, so this is what the conversion of the cut. Okay, so the cut will convert 0 to 10 volt into 0 to 4000. Or sometimes they will use an hexadecimal.
Resolution is meaning what?
Resolution means that is the what? The conversion value, the conversion rate.
The conversion.
Yes.
Okay.
Okay, good. Okay, now. So we already get all the data we needed. Okay. So now what we will do? I have a injector. Okay.
But let's say for a 500 to create the output is actually for all the output.
Yeah. All for both the box. Okay. So you see, this is a normal injector. It's not a device. It's just an injector. Means you can inject voltage and also medium. So to test the analogs for training we use. Okay. Later we have a temperature sensor. We can connect temperature sensor. Okay. So I want to use the voltage. Okay. So this one and power up first. This one ground is the so this one will power up this, and here can you see input, right? Input can be voltage VI1, voltage input 1, or II1, current input, or voltage input to current input. Either one I can use. Output only voltage. Okay. So that's why I counted this. So the first one is the voltage, right? So is the analog voltage out from this line. This one out means one in. Okay. Common. Common is this one, right? Common is and number 5, but I only connected 3 cables. Voltage 1, then voltage 2, then on. It's good. Okay. So now, this one you just can click. This can inject any value now. Okay. Now you create a new project. CP1L CP1LE. Yeah. Okay, go to setting. This is a EM, EM40. No IO. No. So we are using Ethernet, right? Okay, good.
We are using the
Yes. Yeah. So always you can see here, I connected 3 line, line 1, 2, 3. So you see, is it connected or not? Cable connected or not? If the cable loose, then 3 is not working.
when you listen the GM also can do like
This is just a switch only normally. Normally they will have 2 things, right? One is the, this one is the modem. Because one is the modem, one is the switch. Normally,
so but they also can do this.
can because This one all just the switches. This is the optical fiber optic coming right there. One is go to where one will go to the Wi-Fi router. It is clearly the Wi-Fi. Then one you can connect to your laptop, PLC, PC, all that. So if you're not using these, so this one all like a switch only.
Because I thought they have one port specific for like talking to connect to them.
No. If you have any ports, you can use any port to connect the one. And industrial, yes, industrial they have a switch. Industrial switches. They have two types. One is one is managed switch. One is called unmanaged switch. Unmanaged switch means it's a normal switch. You can do anything. Okay. Managed switch means you can give priority to which switch to which port to send signal first, the baud rate, the speed setting, all that you can do. Okay. Now, no need to do it. Just go online. Go online. Yes.
Transfer.
No time. Go to view, window, watch. You key the address 2980. Can you see? You can see some values here, right?
Yeah.
But it's in hexadecimal lah. Okay? Correct. What I want to do, you just double click, change to integer. Okay. Can you see some value. Now you just decrease the value.
Yeah, that's my question is like just now I mentioned
Unit is on off contact.
but even I put in integer, the address like yesterday I set 100.1 is also come out this way. That is a channel.
100.1.
Yeah.
If you key in here 100.1,
address, yes.
you can select integer. You only can select boolean.
Unless I put the unless I address I put as
Okay.
D1 is a whole channel.
D1 is the whole word.
Whole
One word.
One is 16-bit.
Yes. So if you want to put China, can I can show you. You can sir. Here. You put just channel 0. Just put 0. Okay, enough. This one make it bigger. Okay, you have how many bits?
16.
You press the button, first button.
What button?
This button.
I haven't installed anything.
What is install anything? No, I don't, because that is programming is different. This one I just monitoring the values.
Because I already got program here.
No. Okay, you see, what I'm doing here is I just monitoring the values. So the program is not important. Of course, the output won't work because there's no program inside. Okay? I just see here. Can you see? The first bit is on. You on second button? Second bit is on. You on third button?
How come?
What? How come?
Means that I haven't do any program inside here.
No, that's why I say when you do program, it means it only on and off the output. Okay? What I'm doing here, I am monitoring the value. Okay? So it means, of course, I cannot monitor output values.
I haven't set anything like an input one.
What's that? No. Okay, you press the input one.
Because the inside got a program already.
No program. No program. I already cleared the program.
Yes.
Okay, you press the first one.
Yeah.
Okay, you see there is a lamp or not?
Yes, there's a lab.
The first input, right? Channel 0.0 is on, right?
Yeah.
Right? So it means here, can you see? channel 0, bit 0.
Mm.
Correct? So you are monitoring the value, means you already connected input. So you can see whether the input is working or not.
Even no program. is
No
there.
program. Program no needed. Why the PLC need program?
To activate it, to make it function.
Okay, but the simple thing is why the PLC need program is to enable your outputs. Correct, logic.
Yes.
To on and off your outputs.
Because this PLC like a delay.
Yes.
Correct.
Correct. You receive an input, you do a program, and you energize the output.
Because even though the channel 1 here, you have a call, and then you have a 1, 2, 3, 4, 5, 6, and 10.
Yes.
In between is actually a delay.
Yes, yes.
The switches
Switches.
but that's why they share the same like put a common positive, here is also common positive.
Yes. Okay. So when there's no program, means your output won't work, but your input can see, monitor your inputs. Okay. Okay. If you want to monitor 0.0, you can key in here 0.0. Enter. Can you see it become Boolean? Now you press the first button. It shows 1. Correct. So you see the difference here. If only channel is a 16-bit. If a bit means it's a Boolean.
Usually we do like
D0 lah. Yeah.
D0, that one is considered a one channel.
Yeah. One word lah. One word.
One word.
Yes. Of course, now your T0, D0 all won't work. Why? Because there is no program inside. So watch table, if you do like this watch table only can monitor the input values.
Okay.
Got it? Understand? Now clear? Okay. So the one on. So now you know the difference between channel and the bit. That is the most important thing. Okay. Alright. So now here can get value. You just rotate the what? Yeah.
Do I need to key the 2981, 2985, 2986?
No need. We cannot. Okay. You key in 2981. Enter nothing. Because why? It's not connected. Because we only connect one analog input.
Right.
Got it? Okay. Can increase. You go to maximum. That's the maximum, is it? 10 volt.
Yes.
Okay. So you're supposed to get 4,000 lah.
Yeah.
Okay, but 2978 is okay, still okay. Because every time we connect, disconnect, that's the reason. Normally the what it will become offset. The values. Okay, go back to 0. Zero is 0 lah. Okay, 10 volt is you get what?
10 volt is around 4,000.
3978 is it? You go to
39.
okay. Okay. So now we need to do the conversion. Okay. So there's two ways. One, we use the SCL function. Means they already have the function SCL, they can use that to convert. Okay? Why we need to convert?
To make it like a degree.
Yes, converting. Because if I just leave it this number, nobody will understand. I can use put a HMI, I put a new number display, I can put channel 2980. It can display the value 0 to 4,000, but nobody will understand. So that is the reason we convert into their unit. Depend on our instrument. Okay, good. that one you clear. Okay. So there's two ways. One is SCL function. Yeah, we have SCL function. One is the max function. Okay. First we do the max function, then later on we do the SCL function. That's two lah. Okay.
This here is called what?
Scaling.
Scale.
Yes.
So that's why all the analog we have to do the conversion.
Yes, conversion first. Then only I will get this temperature value. After I get the temperature value, then only I do the comparison.
They do have an actual sort of kind of straight away to show you nothing like
They have only for temperature. They have like, but the CJ series lah. CJ series or this one, the additional modules the expression, they have one module for temperature controller. Only that where this one directly can connect. But that one they don't call analog input. That one they call as a temperature. We can call it like a temperature input lah. I have one example actually. I don't have for this. This one is analog, this one for analog level. You see, this is normal analog input. You can see, it's normal analog input. The voltage and current you can use. Okay? This is the temperature input. Thermocouple, can you see? It's a temperature input. So it means
thermocouple is the temperature.
yeah, temperature probe. Probe to measure the temperature. Thermocouple. I have it.
Measure the temperature.
Yes.
I heard the terms always also.
Thermocouple or sometimes they call it PT. PT 100. PT.
Is that necessary to have a thermocouple for the ADL system?
Not necessarily. Wait, I'm not sure. Okay, see. This is the thermocouple. Measure the temperature. This is a temperature controller. Means you can see the value. At the same time, this controller can convert this temperature into 4 to 20 millimeter. That is number 15 and 16. Can you see? Number 15 and 16. 4 to 20 millimeter. Okay? So you see now. You take the card. So let's say I discuss. If I am using this card, the normal analog card means I need to use the 4 to 20 millimeter. Okay, connect here. Of course, they will have some value like this 0 to 4000, but element not 0 to 4000, to some number. Then I need to convert, need to do scaling, convert into temperature. This is a thermocouple card. Thermocouple card, I can directly connect the thermocouple. Directly connect here, I straight away get the temperature. Got it? Okay. So that's the thing.
Just give it that because this one already have a direct.
It's a because yes, it's a direct thermocouple. You can read the thermocouple value.
Only for temperature.
Only for temperature they have.
The rest will need to go through the.
Yes. Because all need to transmit. Okay. If you see deeply into analog,
Omron they do not have for this
temperature.
Got also.
But I don't have lah. That's it. Because this one also last time, because Omron, I mean the Adam last time we buy 3 unit second hand refurbished. So from one of the unit we get this. Okay, you know what happened is, okay, why I need a transmitter or a temperature controller. Okay. Okay, so why we need a transmitter or temperature controller? Because you see the probe, okay, they have 2 types. One is called thermocouple, one is called PT, RTD. PT, yes, RTD. PT 100, PT 1000, PT 500. Okay, RTD. So the thermocouple will be in millivolt if you measure lah. Okay, the two positive negative, right? If you measure, you will get millivolt. RTD will be in ohm if you measure.
Oh, that's the resistance
Resistor.
term.
Yes. Okay, resistance will be there will be resistance in PD.
RTD resistance called
It's a resistance.
resistance.
Okay. Okay, you see now. Our analog input, you see, our analog input only can read these two values, voltage or milliamp.
Okay.
I cannot read millivolt or ohm.
Okay.
That is why I needed transmitter.
Okay.
Okay? Or I can use directly a temperature cut, temperature control. But if you see like pressure sensor, why the pressure sensor they don't have like their own inputs? Pressure sensor. Okay. How the pressure sensor measure the pressure? How? Okay, if you see logically inside, if you go inside, but I never go do research how the pressure sensor works. Okay. What I think is, of course, there will be some resistance, something inside, some resistance. So when the pressure increase, the value of the resistance will be increased. Or when the pressure decrease, value of the resistance will decrease. So they will convert this value, that's what they call transmitter. Convert this value into voltage and milliamp. That's why the pressure, the flow, the humidity, all they cannot directly, they don't have something that directly read. They must go through the transmitter. It's always attached with the transmitter. Come with the transmitter. Like a pressure, humidity, everything. Only the temperature, they have a temperature probe and transmitter. Two different things. If you're using analog, you need to use transmitter. If you're using a thermocouple cut, you directly can connect. Okay? Okay?
Which the transmitter you mentioned here, your mention here is referring to which bus device?
Yeah, you go to Google. You just put it here. Temperature transmitter. Okay. It's a many type transmitter. Okay, got up? Okay, like this. So you see, like those so many, right? Okay. There's a two terminal. You will connect the thermocouple. Thermocouple. There's two terminal. You connect to the PLC. Okay. No, the probe. The what? The probe. Okay. You go to pressure transmitter. So because it's a different probe is different, transmitter different for temperature. Okay, you put pressure. Yes. You see, measure the pressure and convert it into a usable figure. So directly together like this. Transmitters. Yeah, you click this one. Think, just click. Yeah, you just click here. Can see now. Okay, now you go close. Pressure transmitter, you go up. Image. Go down. Okay, like this. This one all they will show here the pressure lah. Straight away they will show you the pressure. Okay. All like this one. Okay. Okay, but then can you see here? The first letter is a 0 to 10 bar. Means the measurement. The second one, can you see 4 to 20 milliamp? That is the analog signal. And the third one is DC 10 to 30 volt. Is the to power up the transmitter. Okay, so this one will have 4 cable. 2 is like this lah, like the one where the potentiometer we just now do.
This one.
Yes. 2 to power up. 2 is the analog.
Okay.
That is okay. Minimize this. Now we go to the programming part. We go offline. You click here. Go to yes, offline. Now we want to do the program. Now what you do, you rename SCL underscore max. Okay. So we want to do one SCL using max function. Another one is the SCL. Okay. Or in front you put AI, right? In front, yeah. AI scale max. So we are using AI scale using max function. Another one is the scaling function. Now the max function. So because why I do max function? Actually I don't need to use max function. Straight away I can use this. Because max function we can learn some other things also. So okay, what we need to do? We need to do a few calculations here. Okay, we need to do a few calculations here to get the M. Okay. To get the M, we need to get the difference between Y max minus Y minimum. Correct. We need to get the difference of these two. Okay. Then the difference of X max minus X minimum. Then only we can get the M. M is the delta Y over delta X. Y over X lah, right? Okay. Then we already get the M. X is our analog input. Y is our temperature. C is the offset. So for now, actually no need offset. Okay. Later we connect the temperature sensor. That one we need offset.
M is the what?
M is the gradient,
Gradient.
the rate. Okay. We do this calculation. Okay. You see now. Yesterday I think did we learn floating point calculation? No, right? We just learned calculation using integer, double integer. Today we learned floating point also. Now you see, Y divide X, 100 divide 4000, what we get? 0 point something. Okay, so which is we cannot use the floating the integer, correct? Because yesterday the integer when you calculate there is no decimal points, right? Because it will go to the next word, next set state is 60 degree. So okay, we use the floating point calculation. Okay, you put the normally open, the P always on, the P on. Yeah. The analog is very interesting to learn. Okay. Anything not clear, just ask me. Okay. Then first we find out this one. If you want to use floating point calculation, this one is a subtract, right? You put dash. No need to choose anything. Just press escape. This one. No. The minus. Subtract.
Subtract.
Yes. F. Yes. Can you see? Floating point subtract. Space. Okay. So this data lah. So we need a data register to key in the data. Okay. Actually I can directly key in the value also, okay, but I want to use the data register. Okay. So D0 space. Okay, next number I can use what? D0, next number I can use what?
D1.
Okay, cannot. Because floating point is a 32-bit, similar to double integer.
Okay, that is a D2.
Yes, similar to double integer, floating point. Yes. Space D4. Okay, enter. The first comment we put Y max. Okay, enter. Y minimum. Enter. Delta Y. Good. Now, same thing. You click here, you can directly put it. Same thing. Minus F space. This one is a new one. So D6, D8, D10. X max, enter X min, delta X. Okay, so it automatically draw the line. Okay, so I can close first. Okay. Later you can put title for this. You know, you can put what you are doing here, everything. Okay, you add another P on. This one is to get this one divide, same thing, slash F space. So delta Y, right? D for space divide D10 space. Okay. The value I will put into a new data D12. D12 is a new one. Okay, enter. So delta Y, enter. Delta X, okay, correct. M is the rate or gradient, is up here. Okay, put M gradient, M rate, or just want to put M also can. M rate, R-E-T. No, R-A-T-E, rate. Yeah. T-E-T. Rate. Alright, okay. So we already get the M. Now multiply with the X, can get the temperature.
Multiply with the X.
Yeah, because we already get the M. C we don't need to calculate because it's a 0. So multiply with the X. X is our analog input. So if we multiply with our analog input, can get the temperature. That's all. Clear? Got it? But now, you see our X, the X means the X axis, right? Which is our analog input.
Our C is a 0.
C is the line here. So the line is at 0, right? So no need to calculate. The C. If the line is somewhere here or somewhere here, then we calculate. So later we do for the temperature. Okay. See now, M we already got the M ready. So just need to multiply with the X, we will get the Y. C no need. Okay. Now the X is our analog input. Our analog input is what? Where from where? 2980. Okay. See. Now our M is in what data type? Our M is what data type?
Our M is delta.
Is it integer, double integer, or float? Float, right? Okay. Our analog, what data type? It's an integer. Because float means we'll have a decimal point number. Just now when we measure, there's no decimal point number. Float will have a decimal point number. Okay, good. Now, so you see, this one is integer, the M is in float. So how can I can multiply? Cannot. If I want to do a multiplication or subtract any calculation, the two data type must be same. Okay. The M I cannot convert to integer because you see 100 divide.
Why cannot?
100 divide.
Straight away times.
Yeah.
That's what we found.
You see, it's very simple. It's very simple. Y equal to M multiply X.
Yes.
Now your M is in real or float,
Yeah.
but your X is in integer. Two different format. Cannot multiply.
But it's so like, for example, 1, 2, 3, 5, 2, 5 times 2.
Hmm.
Yeah.
Cannot. In PLC, both if you want to multiply that. This one only can work in Allen Bradley.
In what?
Allen Bradley.
And all everybody.
Yes. Others cannot. To show error. Because not same data type.
Okay.
Okay, good.
Okay.
Now, so now either the m I need to convert into integer or the x I need to convert into real. Okay? Okay. Of course, the m I cannot convert into integer.
Okay.
Why? Because this value, right? This one is what?
Yeah.
100, right? Divide 4000. So at m you will get 0.025. Yeah. So of course this number cannot convert to integer. If I convert to integer, it becomes 0. Okay. So the thing is, this value we convert to real. Okay. The x value, if the format is integer, I want to convert the format into real.
So it becomes 3978.00.
Yes. Okay, can put always on. Okay, so the conversion function we call is just keying here. Don't need escape. FLT. Think so, I also know it. FLT you key. Yes. Can you see? 16-bit to floating. Space
16-bit to 14, 16-bit.
is an integer, floating means it's a real.
This one integer.
Okay,
So
space.
become 32-bit.
Yes.
Okay.
Space. Okay, our 16-bit is which one?
Our 16-bit is 81.
No, this one 2980.
Then
Ah, 2980.
G2980.
Yeah. It's a channel, space. Okay. Of course, this data I want to convert. I need to put into a data register, a D. So D available D is 14. So yes, 14.
E14.
Yes. Enter. Wait. Okay. 2980 is the AI1, right? Okay. You put AI1 space INT, integer. Okay, enter. Okay, this one also same. AI1 space is a real. Yes. Enter. Okay. So this is a 16-bit to floating, means we convert the AI1 in integer, we convert to real. Okay, why? Go down. You put it here. Always on. P on. Okay, but actually all this, right, in one run also I can do. Okay, I just do a thing. Okay. Now y equal to mx plus c. So multiply, right? So you put multiply f.
Multiply
F.
floating.
Yes. Space. Okay, what is our m?
M is the D12.
Yes, d12.
D12.
Space. What is my x?
Your X will be D12. S will be the D14.
Yes. Space. So the new y will be the new data register D16.
D16.
Yes. Enter. Okay, M read, correct? Enter. AI real. Alamat last one I want to put name. No, just double click. Enter. 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 Okay. Temperature. Okay. That's all. Okay, good.
I could have realized a calculator.
This one is
floating to
no. This is not floating to calculation. Okay, this one is calculate the delta y and delta x. Calculate
correct now. Count.
CAL, right? I think your L is not properly working. Yeah. Okay, calculate delta y and delta x. In floating point. Yes. So in bracket you put real. Real, yes. Okay. Yep. Okay. Same thing here. For this one. Yeah. Yes. Calculate the rate. Calculate the rate. In bracket you can put gradient.
Gradient.
Yeah. Okay. Then this one, yes. Put it here. This. Convert AI
From integer to
real. AI you put 2980. In bracket you put integer. To real. Yes.
floating.
Okay. Then last one is the y equal to mx.
Calculation.
Calculation lah. Y equal to mx. Just put mx. Then you can mx. Yeah. Calculate the temperature. Or the heat plus C also can. But you are not doing C. Don't have C here. No C. C0, yeah. Okay. Linear equation. Okay, good. Now, download this. Safe transfer. Yes. Okay. First thing you see here. Can it change to float number? The others don't care. Others don't care first. The floating. Okay. Can get. Now what you do? You key in here. You go all the way up. What is your y max? Okay. Put it here y max. D0. Enter. Change to float.
Rear is called float.
Yeah, rear is the floating point. Okay. Then you just double click, automatically D2. Okay. Next is D6.
D4.
D4 only. D4 you can see. Put D6 here. No. Double click. Just put D6. Okay. Then double click. Okay. Then last one, where is your temperature value? Go down.
D12.
No. Go down. Temperature.
Temperature value.
Last one. D16. Okay. Now, because you see got some funny values, right? Because we haven't put the Y max, Y minimum value. Okay. You put the Y max 100. Okay. Yes, monitor. Yes. No. Okay. And yes. Then D2 is the Y minimum, right?
D2.
You close this. Comment. Why no comment? No, never mind. D2 is what? You go up here. Y minimum. Okay, Y minimum 0. Y minimum is 0. Right? Y maximum, Y minimum 0. Okay. Then D6 is the X maximum.
D6X 397.
Ah,
Interkey.
yes,
D6. Max.
397. Actually supposed to be 4,000 lah.
You not prefer 4,000 or prefer 397?
You can put 4,000 first lah. Okay. Now,
Minimum is 0.
okay. Now what to be? Minimum 0. Okay. Now what is your temperature value now?
It's 99.4.
99.45. Okay. But that one is the 10 volt. Correct.
Correct.
10 volt means maximum lah, right?
Yeah.
Means it's a maximum temperature lah. Okay, but you get 99.45 because your actual is 3978, but according to the format is 4,000 lah. Right. So now you change to 3979 or 78. Now you get 100. Got it?
Correct.
Can any question?
My question is now simple. Let's say for example I'm the programmer, I write all this, I did not put a remark there, so I will have to write down and I look at other programs. So many of calculation. If no remark, then I have to write down how this formula they form out the formula.
Yes.
Otherwise,
Okay, if they
confusing, right?
Yeah, of course. Let's say this one they don't have remark, right? So
Yes.
how I will find? Okay.
Yeah.
The first thing is the 2980. Go to the address 2980. Go down.
Always go to the last one.
No, not always go to the last one. Okay, where is the 2980? Okay, because this is the analog.
Okay.
I don't know what they doing, how they do, what they do conversion or what type of calculation they do. I don't know, right? Okay, so I will find for 2980 first. Okay, so from here I understand that they convert this value into a real, that is D14, right? Next I search the D14. Where the D14 is using? Is using here. There's some multiplication, they use the D14, right? Okay. Then D14 multiply with what? D12. Then I find where I use the D12. Here, right? Okay, this D12, they do a divide, which is 2 data. Okay, now first I will go where I get the D4. Go up, okay, this one. From here, so there's 2 value, is subtract, I get the D4. Okay, go down, okay. Then where I get the D10. So I here, there's 2 values subtract, I get D10. So I know, there's 2 values subtract, go to 1, D4. 2 values subtract, go to D10, right? D8, sorry, D10. Okay? Then they divide these two. So that's how I can know how they do. Unless they put like this lah, something.
Can I just find the
Of course. Of course. So there's only one place they're using. It means in the HMI they need to key in something here. From the HMI they need to key in for D6.
D6?
This is what Xmax does. Because this one you key in is you manually key in, correct? Means it's like from the HMI you key in the set points like parameters, settings.
Oh, okay. But like for the analog side, right?
Yeah.
For the analog, why the fee? For the analog, why you the number?
Which number?
The HMI and asasmy.
Yeah, of course. This one you need to do.
This is a formula, HMI and asasmy, right?
You mean this one?
Yeah,
Yeah, that's a formula.
HMI and asasmy is from the table. So
Yeah.
how you key the
Yeah. Actually, you see, if you ask me, right, actually these two no need. Right? Because the minimum value is the 0 only one. Go down. Scroll down. No, scroll down here. I straight away can go to scroll down. Straight away can go to the find out the gradient, right? Because I know what is the y, because y is 100, x is 3980. Sorry, 3970.
Yes.
So I don't need to do this y minus this one to get this one. Correct. Okay, but that is the formula. So I like to use the formula. You know why? So you know what I mean here? That is, what I mean is I don't need these two calculations actually. Because 100 minus 0 is a 100. 3978 minus 0 is a 3978.
Correct.
So actually I don't need this. Straight away I can do this calculation. The divide. So I divide, get the n, then do the conversion, then do this calculation. 3 calculation enough. One to calculate the n, one is to convert, one is to the last calculation. 3 enough. Okay. But why I practice this way? Let's say the sensor you buy is not 0 to 100.
How do I know the sensor I buy is not?
Remember just now the pressure transmitter.
Yes.
0 to 20 bar.
0 to 10 bar.
20 bar. Oh sorry, 0 to 10 bar.
Okay.
So means it already give you the range. So when you buy a temperature sensor also it will give you the range. Let's say the range is
Like for example, here got mentioned.
negative 25 to 100.
Oh,
Let's say the range is negative 25 to 100. So you will do calculation like this. Okay? Now your minimum maximum already different. It's not 0. So in this calculation, you need the Y max, Y minimum. You need the offset as well. So that is the reason.
Yeah, for example, here mentioned 4 to 20
Mm.
millisecond. So
Milliamp.
milliampere.
Means here can I erase this?
But he started at 4.
Yeah, can I erase this? But the calculation, that one you understand, right?
Yeah.
Okay. So I just do a sketch. I just do the graph for this. Okay. So if this one means what they tell you is AI. This is the pressure, right? Okay. Right.
Yes.
Pressure. The pressure is 0 to
10.
10. Sorry. Then it's a 4 to 20 milliamp. 4 to 20. So 0 to 20 milliamp means it's a 0 to 2000. Right? So 4 to 20 means what? So 4 to 20 means it's a 400 to 2000, the range. Correct?
4 equal to 400.
Because 20 is equal to 2001.
Just like wow.
Yeah. Okay, good.
Ratio.
Yes. So start with 400 until 2000, right?
Yeah.
So means the graph will be like this. So it means
Plus C will be 400.
what is it?
Plus C will be off. Okay.
No, always the y-axis.
Okay.
So now I need to do this calculation first. But the y minimum, of course, I will use 0. No, I don't use this area because the y minimum where it stops is here. It's a 0, right? Because our pressure is from 0 to 10. Okay. The x and x max, x minimum for 2000 minus 400. Then, so I need to do this calculation, need to do this calculation, need to do this calculation. I need to find what is C.
Y minimum is not minus.
No, that's because we don't know what is this one. Right? So y minimum always your range. Because why? Because that's why I put dot dot dot.
So in that case, this one we need to do the calculations. Because like for example, 4.
Yeah. Yes. How many calculations we need to do? 1, 2, 3. To find out the C, I did 2 calculations.
To find out the C, the calculation.
Yes. Then 1. 7 calculations.
So it means that every time we have to depends on what kind of product.
Yeah. Of course. What is the instrument we use?
Wow. A lot of things, just only small part we do a lot of calculation. We don't know, we just based on the default.
Yeah.
Right? We cause any issue.
What default?
Like for example, by default I'm using that linear one
It's also linear also.
plus 0. C.
No C, yeah. No C means then it will become wrong value.
But how come the device is sometimes correct? Do the calculation like that. Then maybe the people do a lot of calculation.
Yeah, that's the thing. You can do calculation or you can use the SCL function, their function.
Oh, their function.
Yes.
Another function.
They have their own function. Where you don't need to do calculation.
Scaling.
Yes. A scaling block lah. So you just need to key in all the data, it can calculate for you.
So now you're teaching me the 14, and then scaling, and then after that max.
No, now is the max function.
Max function.
This is the max function. So next we can do the scaling function.
Scaling will be more straightforward.
Most straightforward means is no calculation. We just need to key in all the minimum maximum values.
Okay.
Okay? But there will be BCD advisor.
Okay.
BCD advisor. Okay? Alright. So this one you can clear, right?
Clear. very good. You are very clear on your mind. A is a positive.
Yep.
Either. Or
A or B lah.
They can be either positive, negative.
Lagi tak? A, B right? A, B. So using Kian's PLC, is it similar? What PLC?
No, here is Sicilian.
The PLC?
This is the robot side.
Robot side.
This is actually robot side Sicilian, right? It's not for Kia, right?
No, not for Kia.
Okay, means this ability they have a card, they just connect this one to
Yes.
the robot. So this is a PLC program. Is that all the PLC program you go through?
Yes, correct.
Through this data
Yes.
to control the
To control the robot, and robot will send the signal to this data.
And this three,
This one is for what?
the
This one is for what? Let's ask this. Sequence board.
okay, second one is not IO, right?
I'm not sure. This one sequence board is for what?
So only this one to communicate.
This one is for communication, but the sequence board I'm not sure for what it is. So what PLC is it? Omron.
Omron. But this one is only for Sicilian.
Yeah, system connection. This one is the internet.
This one is internet for camera.
No, I'm not sure, but it's just keys.
So this one like what you said.
The switch, yes,
Switch.
SOSA.
Some is a switch, right?
Mm.
It's what you say? Just
Unmanaged.
unmanaged switch. Just like this one.
Yes.
That's why they are means that they are this one they are not using for robot control, they are using more for communication, internet. This one is asking them now I want to check what is the device they are using. And find what PLC. So now I have that.
Yes, they use it, yes.
Here is the PLC.
So if they're using keys,
Yeah,
that's why they
this
use
project
keys.
is not us, we just only do their robot program. That's why
The PLC they're using keys,
they're basically they're using PM and vision, we just do the robot program. So that's why I want to know how they do the communication with the robot like this. Now that's why the vision is so
Okay, do you have the robot, the part number?
robot
Your robot model.
yeah. Yeah, I have robot program.
Okay. You give me the model number, I will just go to the manual and see how to do the communication. Now, go offline. Yes. Right click new or insert section. Section, yes. You put AI SCR. Okay, good. Okay. Go to AI SCR. You put always on. P on. Okay, good. Now, for that, okay, can I erase this? For this, what we do, we use the temperature sensor. Okay. Okay, the manual is there, right? Just now the CP1E manual.
Yes.
Okay, we go to the manual. Okay. Yeah, save it. Okay, we don't only we open here because easier to see here. Okay, and what option we got? Okay, just scroll down and just scroll down. Okay. No, go down some more. Go down some more. Go down, go down, go down. Go down some more. Okay, you look for MAB221. Go down. MAB221. Go down. Go down, go down, go down, go down. Okay, this is the one, MAB221, right? This one is ours. This one, right? Okay, go down. Go down, see the wiring. Okay, okay. See, yeah? Analog input. Okay. How the wiring works, huh? Okay. See, if using the voltage, right? So analog input here. Okay. So V voltage, current, and one common, right? Okay, go down. Slowly go down. Okay. Wait. Slowly, quickly, go down. Go down. Go down. Okay, you see here for input, if voltage only means this voltage and common. If a milliamp, you see, if a milliamp, it means you see analog device with the current output. This is current, this is a voltage. With current, the positive must be connect to I and look to the voltage. It will be looked. Okay, can you see that? Okay, so we need to do that. Okay,
This one is
voltage, that is this one lah. Our this one, you see?
Listen to
one, then this one go to the common. Okay. The first one. So the first one will be the. Now we want to use the second one. So for second one, I want to use current. Okay, the current. Now I want to use current. So what I do, the negative one, because you see this is 420 million, right?
Okay.
Okay. The negative is number 6.
So small.
Okay. So number 16 is a negative, right? Okay. So the negative I connect to the COM. Okay, so I just join this guy lah.
Sorry, we have so many of them. Why choose 16?
Because 15 and 16 is the 4 to 20 million.
Oh,
Yes.
because this temperature of 4 to 20 million.
Yes, this is the okay.
Not
Also
zero
right?
or 20, yeah.
No, not 0.
So this one we have to put the constant.
Yes. Okay. Then number 10 and 10, 11, 12 is for the 10, 11, 12 is for the sensors, the temperature. So if you're using RTD, normally RTD will have a 3 table. So 10, 11, 12. If you're using thermocouple, TC. Using TC only 11 and 12. So we are using TC, thermocouple. RTD 10, 11, 12. Okay. Then number 7, 8, 9 is the alarm. Here. Okay. That means because this is not a transmitter, this is a temperature controller. It means here also I can do some set points. Let's say if the temperature more than 80, alarm 1 on. So I can use the alarm. And also this one got out 1, out 2. Out 1, out 2. Okay, this one also same. You can do like 2 set points. Okay, like 50, output 1 on. At 70, output 2 on. Okay, 5 and 6 is the power. Okay, 1 and 2 is the like the input for this. So to control something, I don't know what is that. Input for this, because this one is like a PLC also or something like PLC, but it's already programmed inside. So you need to do some settings.
So we 250.
We just because what we do, we connect the thermocouple to 11 and 12. 15 and 16 we just bring the analog value. Okay, good.
So 11, this one is just only for plus minus.
Yeah, plus minus the thermocouple.
This one
11 and 12.
12.
Yes.
How to see how we starting from?
Okay.
What number?
Then 15, 16 is the 4 to 20 million. No, don't see thermocouple is not there. This one is yes, analog device output is this one is the 4 to 20 million.
Okay.
So 4 to 20 plus and minus. Okay. So the 4 to 20 minus is direct go to the COM, right? Okay. That is number 16. Correct, number 16, right? Number 16, I go to the COM. So I just connect this guy lah, this COM.
So we have another one we need to connect with the CD and the RGs to connect together.
Yes, connect together. Good. That is what I want to do is okay. So number 15 is the positive, right?
15 is
Here. Means number 15 is the positive, right? So I go to the this one. Which is connected here to the V2 voltage lah, voltage. Okay. But if I just leave it like this, it's the voltage. But ours is the current, right? So the VI2 and the I2 must be looped, right? The current and voltage. Okay, so I just use this.
small cushion. How you push this error to the car? Okay.
420 milliamp is the current. Voltage means they will put voltage.
Okay.
And this one is it.
Okay.
This one is the voltage. So just voltage plus voltage negative. But here is a milliamp. That's the current.
This is power supply. This is this one is current. This one is
The temperature. Okay, good.
Okay. Yes.
But you understand the concept here. Means very simple.
Yeah.
With the function of this one, you measure the thermocouple, and actually this one can control also. Can on and off at the same time, can show the value. But if I want the temperature value in my PLC, so I connect the 420 milliamp to my PLC. Got it? So temperature,
Maybe that is all from.
one by one, learn, training. 10 years.
Yes.
So this is the reading we want to put in our yes. Okay, good. Now before any program, the best practice is okay, now we are using the second input.
Okay.
What is our second input? AI 2 is the 2981, correct?
Okay, I 229, correct?
Correct? Got it? Now we need to do the graph. AI 2, which is 400 to 2000, correct? Analog value, correct. And I want to convert this value into 0 to 100, because the temperature can measure 0 to 100. So this name I put temperature 2 lah, okay, because just now earlier we do the one, right?
Yes.
Temperature 2. You all have this, okay?
Yes.
Clear?
Clear.
Now we want to use the SCL function. Okay? SCL function. We have 3 data.
Okay.
So SCL function we have the 3 data. That is the input and the first parameter and the result. Okay? So means are very simple, you know. You know what is this? Input is our X. Okay? Actually they don't call input, they call source.
Okay.
Okay? Then the result is our Y. Okay? Then the first parameter, it means this one has a 4 parameters, right? Correct. Y minimum, Y maximum, X minimum, X maximum.
Correct.
So we have 4 parameters. Number 1, number 2, number 3, number 4. Okay? So minimize this
Parameter referring to
the minimum, this the y-axis and the x-axis values. That's all parameters. But you don't need to put all the 4 parameters. You just put first parameter. Automatically we use 4 data. Okay, I'll tell you how it works. Okay, minimize this. You go back to the SCL Max. Okay, until what data register we already used? Go down. Until the D16, right? Okay, you go here. Okay, we start with D20 lah. Okay? So you just key SCL space. Okay, can you see? They call source word. The first one lah. Okay. So our source is what? 2981. Put that because our x-axis is what? 2981 space. The first parameter word, it means, okay, we start with D20 lah. Okay, put D20. Okay. You see, if you put D20, it means it's automatically the first, means here you just putting the first parameter. Actually got 4 parameters. So automatically, in this one we'll use D21, D22, D23. Okay, but no need to key, automatically we use. Okay, automatically we use. Okay, I will tell you how. No, escape. Okay, wait, D20. First parameter word, okay, space. Then the result word. So the result must be the next one. So I already used up to 23. So next one available is D24.
okay.
Enter. So the 2981 you put AI2. Okay. D20 don't need to put in, later we put in. Then D24 is the temperature 2. Okay. That's all. Okay. Now what we do, we go to help to find out number 1 is which parameter, number 2 is which parameter. So normally it will be like this. If not mistaken, x minimum, y minimum, x maximum, y maximum. Okay? Okay, go to help. CP1.
We are using CP1.
Sorry, CP1L. But it's the same thing only, instructions. CP1L. SCL. Okay. Can you see? Source word, first parameter word, result word. Okay, go down. Okay, see so P is the parameter word. Okay, P plus 1 is the second one. P plus 2, P plus 3. That's why I put 20, 21, 22, 23 by default. Okay, so your D20 is actually what? AD, right? It means the Y minimum. Okay, so the Y minimum. Then the second one is the AS. Correct? Okay, you see here.
D20 is the one.
AD, right? Where is the AD? Here.
Okay.
Y minimum. Second one is the AS, right? Where is the AS? Is the X minimum. Then the BD is the Y maximum. Okay. Then this is the X maximum. For them they just put point A, point B lah. Then point the S, point A. Actually, you know what is this S lah? S means is sign. R is the unsigned BCD. Now, the most important part is not this one. The most important part is
Unsigned means that 0 point to something like
yes, 0 to 65535.
plus minus.
Yes. Okay. Now, the thing is, the most important thing is, this one, according to this, when you're using this one, right, the SCL function, okay,
Yes.
this is BCD, this is binary, BCD, binary. When using this form, this scaling function.
BCD binary. BCD binary.
It means your y-axis is a BCD, x-axis is a binary. That is their format. You need to know.
Because data type, right?
That
Is it considered as a data type?
no, BCD and we call it as a format. Data type is the integer. Can. It's a data type. BCD, integer, double integer, floating, all data type. Okay, now minimize here. Now this is where you're going to be tough for you. You download this first.
No, we should. Okay.
Okay. Now what you do? You key in here D20. Okay, wait. Is that D20 is what? BCD, right?
Yes.
Put BCD here. Double click. Unsigned integer BCD. Okay. Then D21 is the binary. So you put D21 is you use integer. Then D22 is BCD. Okay. Then D24. Sorry, D23 is integer. Now, D24 is the result, right?
Yes.
Correct. So your D24 is in what format?
You may digest.
Yes.
CD 24 is what format? Because input is the it's a float.
Your D24 is what? Y. Your Y is what?
Temperature.
No, the format.
One
BCD.
is a BCD.
Means
Why does it
format here is a BCD format. This is in binary format.
Okay.
Because we are using the SCL function. We are not using our own calculation. Our own calculation can be real, floating. Okay? Now we are using the SCL function. We need to follow their formats. Okay, good. Now, so you key in D24, you put BCD format. BCD. Okay, now you key in all the data. Y minimum, Y maximum, X minimum, X maximum, you will get the temperature. Because if you choose the correct format here, then only you know.
Okay. BCD is 25, 26.
What is the temperature then?
26.
5 to 6, right?
36.
6. Now what is the temperature?
55. So this is temperature or 37?
This is temperature.
37?
37 is like a set point.
Set point.
Set point here.
Oh.
You get this, you know, the output alarm for that function lah. You don't get that one. Just get this.
45. So BCD. So as this SCR function is actually for temperature.
Not temperature, any
But
also
the
can.
BCD, in terms of BCD, that one is considered as a degree Celsius.
Yes, yes. We just see the number. Format at the back is different. Okay, it can be BCD or binary. There's a two things of Omron. Okay, so BCD means, it's a BCD format lah. Binary means it's like a normal number, normal decimal number. Okay, so normal decimal. So this is the format because why? The data type is different. Data type is the integer, 16-bit, 32-bit for that. Okay, now. So, but now you need to key in manually here, right? So how to automatically, if I take out the battery, right? If I take out the battery, what happens? All this value will gone, correct?
This battery.
If I take out the battery, what happens? All this value become irregular numbers. So let's say the power off and on, all the value will go. So I always want to, because this value are fixed value.
For example, now I turn on the power, it will become
Not immediately lah.
Because
It will take few days lah. Okay. Now, but you cannot every time you key in these numbers, correct? Must be like something like always on, right? That is where we will be using the move function. Okay. Now we see move function. You see now the watch table is similar to your HMI. Means you key in values. You cannot because these numbers are fixed numbers. 0, 400, 100 and 2000 is a fixed number. So we cannot always go and key in the values. So must be that. But we cannot key in here, correct? We can key in the scaling block because you only allow to key in only one parameter word. If let's say it allows you to key in 4 parameter words, then you can straight away put the values there. go offline. Now we see how to move the value. Go offline. Okay, now you add the P on the second line. Then you use move function. Escape is escape. Move space. No. E take up. Okay. Move. Okay. The first one is what? D20, right? Right. D20. Wait. Don't key in it. Okay. D20 is what? The Y minimum. It's in a BCD format. Okay. So we know BCD format. What symbol we will use?
BCD as a hash.
Yes. So you put hashtag 0 space. Okay, where you want to move? Space. Where you want to move the 0? To the D20. Put D20. Okay, enter. Now D20 you put Y minimum. Okay. You close this one. So now no need to do. Now you click here. Same. Another move. Space. Now the second one is the X minimum. X minimum is in binary. So binary what form? What symbol we use? Yes, use that symbol. Zero. Okay, where? D21. Yes. Yes. Then for Y maximum, Y minimum, same thing. You do.
What do you have there?
Yes. Yes.
S0 as well.
No. Y max. Right. Y max is what? BCD. What is that? 100, right?
Yeah.
So
200.
hashtag 100. What? Yes. Okay, now download. So now no need to, in the wash table you go and key on. Okay, good. Now can you get the value? Now you don't need to key in. Now what? You go to wash table.
I haven't done.
Oh, I haven't downloaded. Now you go to wash table. You close this one. Close this. Open wash table. Now you try to key the value here. Try to change. Yeah, right. Try to change to any value. Cannot. You know? Big reset. Because already set. How I set? I move value. That is the function of the move. Move is very simple. I move whatever value at the source, move to my destination. So that's why your machine got so many move functions. Means they set values. They fix the value.
Move is to set value.
Not necessarily set lah, but it's like moving a value.
The scaling is actually for
Scaling is actually to convert the analog value into a engineering unit actually.
Okay,
Convert the analog value to engineering unit. Any question? Okay, good.
The 2981 is actually from here. The value from here.
Yes.
Here.
No, the 2981 at the option board.
Option board. Okay.
The address 2981 is at the option board.
What the value is there?
This value for 400 to 2000.
Option board. So this is from here.
Yes,
No,
that
from-
one, yes.
From this one.
No. The temperature controller give 4 to 20 million to the PLC. Then the PLC will convert that 4 to 20 million into 400 to 2000.
And this temperature is
That one is the temperature. That is measure the temperature, give the data to the controller.
I need to find out.
Okay, I will draw a tree here. You see. Now, this is the temperature controller. Okay. I connect temperature controller will convert this data, same positive negative, into 4 to 20 million and connect to my the AI option board. Right. Okay. So what I'm I just do the wiring so we can understand better. So this data is about to 20 milliamp, right? So this one go to the COM. Okay, and I look here, it is go to the VI2 voltage input 2 and also the II2, right? This one is what? My analog input option board. Okay, then this option board is connected to my PLC. Okay, so the function of this analog input is convert this value into 400 to 2000. Okay. So now what is our function? Our job to do is convert this value to temperature value. That's all.
So your input 2981 is actually what value?
It's not a value.
It's not a value.
It's the address.
Okay.
Your channel.
The channel.
Yeah, it's a channel.
The channel inside got value, right?
Yeah, that is the value here.
This is the value.
Yes.
The actual value from the thermocouple.
No. What? You are confused. Okay, where are you confused? Okay, which one you don't understand?
Calculation roughly I know.
The calculation you leave. Now, you know what is 2981? 2981 is what actually?
It's the address of the analog
Input
number 2. Number 2, correct?
correct? Okay,
The
that one is
the address for store.
That's
store.
huh?
The address to store.
Store the data, store the value. Okay, good. That one is okay. Now, 0 to 100 is what value?
0 to 100 is what value?
It's the temperature value.
Okay.
So thermocouple will measure this temperature.
Correct.
Send the data to your temperature controller.
Yes.
Okay, that is the controller. What the controller do? Controller will convert this value into 4 to 20 milliamp.
4 to 20 million.
And I take the 4 to 20 milliamp, I connect to my analog input. Okay, so I connected to number 2 here. Okay, so number 2 is the 2981
You connect to
and analog input number 2 lah,
okay.
which is the 2981 address. Okay, then so my function of analog input is actually what? The function of analog input is actually convert the analog value into this one. Actually they call digital value. That's why normally they call is a AD module. Okay, so they call AD module, analog to digital module converter. Okay, good. Now we already keep. So in the PLC, we get this value. So where I store this value, where the value will be stored is in 2981.
Correct.
Okay. Now the job of the programmer is to convert this value into what is my instrument. My instrument is actually what? A temperature sensor which can measure 0 to 100 degree. So I need to convert this value into 0 to 100 degree. So that's why we do the SCL function. So in the SCL function, you put the input, the parameters, the result, it will calculate for you.
So it means that 2981 is the address to store this 400.
Yes,
Right?
yes.
Okay. To store this the current
Your analog value lah, to store the analog value here.
the analog value is not because this one is the current 4 to
20 million. Yes.
Yeah. But that one is called what value?
Actually,
it's a current, not current.
no, it's not a current, no unit. Okay, this one is the analog value. This one we call, according to this one lah, we call digital value. Yes. That's what they call AD cut. Omron and Mitsubishi, they use this term AD.
That's why I asking you the
Yes.
291 is what value is digital value to store and use the SCL function to convert back to the result D24.
Convert back to the temperature. Convert back to your instrument lah. What your instrument?
Surprised that using this BCD.
Yeah, BCD binary, because that is the format of SCL lah. So that's why I don't like to use
that calculation.
their calculation format. Because you know why? Because at the end the result is in BCD. So later on, if you want to do some comparison, all will be difficult.
They can do comparison, right?
Yeah, of course, that is the whole function of the SCL. The whole point of SCL scaling, not this SCL and also our calculation, is to do comparison.
Comparison for later.
That's what we want to do now. Okay. So,
Understood.
but this scaling, you understand, right?
Yes.
Okay, good. That's the main thing. Okay. Now, after scale, what is the purpose of the scale? After scale, what we do? Okay, you add one more section. Okay. No, one more section. You add. Okay. Just what name? Just program lah, no AI. Just put program. Okay. You open the program. Okay, now you put normally open. Just put a start stop motor. A simple program, start stop motor.
Always on now.
No. Start stop motor, the normal. Push button start, push button stop, motor on. Lamp or motor.
You need that function.
Latch, yes, I want to latch.
Okay.
Stop. Now, thing is, what I want to do is, okay, when the temperature, now what is the temperature?
27.
27 lah. Okay, let's say the temperature reached 29. I want to off the motor. How? This is where we use the compare function. Okay, put it here. No, I don't want normally. Only normally open, right? Only normally open. Just put it there. The symbol of more than. The symbol. The more than symbol. More than. Greater than that, okay? Greater or equal, okay? Greater or equal, yes, okay. The D, I want to use the D. D24. Space. Okay, this is the thing you need to understand here. Okay? Okay, now, very simple. So the compare is means whatever value at D4, I want to compare with, let's say my set point is 29, right? Okay, so if you compare, so the block will be like this lah. Then if this one is okay, then it will give the signal. Now, the thing is, we can't put number like this. If you put like this, it consider channel, not value, because we need to understand channel is not value. Yes. So we need to put a symbol here, either hashtag or the and symbol. So to put here the symbol, we need to know what is this format.
BC.
Yes. So hashtag. Yes. Enter. So it becomes like this, right?
Alright.
Okay. Why red color? Because the line is not completed. Okay, you give one output.
Wow.
Oh, the output. Quite, yes. No, at the line on. No, on the line, yes. So, very simple. That is, when I start the motor, right, when the temperature reach the, when the temperature is greater or equal to 29, I want to off the motor. Okay? So, I need a bit, a memory bit, correct?
Okay.
Okay? Now, what memory bit I want to use? Okay, actually, I have three types of memory. One is the channel, the unused channel, which is 10, 20, 10, 11 or unused channel, the work bit, the holding bit. So I have three types. Three types of memory I can use. So the channel and the work bit is similar. Okay? The holding bit is the one which can keep the value even though I power off and on. So it's up to you which one you want to use. So in this case, I don't need the holding bit. So either I can go for the work bit or any channel. So it's up to you. So we use one work bit. Okay? So this program we haven't used any work bit. Right? So you use W0.0. WW. Okay. And then the name you put motor off. Space. Off. Okay. Then you put normally close here. W0.0. Okay. Okay. Alright. Save, download. Download first. We haven't downloaded yet. It's okay. temperature now?
27.
But here it's showing 41, right?
Why?
Something wrong, something wrong. Okay, I know what is that.
Yeah.
Yeah. Okay, but here it's showing 66, okay? Why? You know why? Because it's showing in decimal format. It's supposed to be in BCD format, right? Okay, never mind, later we will see. Now you go to the AI scale, you know why? You go to here, you go up. Go up. Your X minimum is supposed to be what? Your X minimum?
S minimum supposed to be
400.
400.
But you put 0. Right? Correct? Okay, that's why. No, wait. That's why the temperature is showing 41. Okay? You understand that?
Because I put it 0.
So because you put it 0, it means, okay, very simple. Go up. Okay, what is the value at the 2981? It's around 830, right? Correct? You understand that?
This one, the tonight, this
Channel.
for, this is channel for, this the value for this
Channel, yes.
Then this one for this one.
Yes. Okay? Okay. So, at what is the value? It's around 830 something. 830 lah, we fix 830, okay. So, it's around here. Okay. So, 830 means it's supposed to get what? What temperature? Huh?
27.
It's supposed to get 27. But your temperature now is getting is what? 41. Why? Because of our graph. Because according to this, what we do the graph like this. Correct. So 830 is higher. So you get 42. Clear? So we change the formula. Okay, wait. Now I'm online.
Yes.
Okay, I want to change. Okay, there is a function called online edit.
Okay.
Okay? Okay. Go down. I want to edit this one, right? X minimum, right?
Yes.
Okay. You right click here. Right click. Online edit. Begin. Okay. Double click here. Change. And 400. Yes. No, not 4,000. 400. Okay. Space. Okay. Okay. Right. Okay. And then right click here. Online edit. Send changes. Okay. Now what is the value?
27, 20.
Here.
27, 26.
Okay. Good. Now go to the program. Okay. But still the format is in decimal, right? Okay, right click here.
This one is decimal.
The n means is decimal, huh? Okay. So you click here.
It's not BCD, it's supposed to be BCD.
Yeah, it's supposed to be BCD, that one is correct. But because the format here is okay. You click here. Take out. Release. You click the second one. Release. Click the third one. Okay. Now it's 27, 26, right? Now you press the start button. No, start button. You press the button, push button. No, push button. No, bro. Cancel the push button. Yes. Okay. auto running. Now the temperature is 27. Okay, you just hold the sensor. Cut off already. Okay, that's all. So for do this program only, we do the scaling actually. You know?
This consider scaling.
Which one?
This one. Move. The
This is compare.
okay, yeah.
Yes. To do the comparison, I do the scaling.
Yeah.
Okay? Why? Can I erase this?
Wait for Surya first.
But the scaling, okay, no problem. If you are not fully understand, no problem. Okay? But you need to understand the concept first.
Okay, but I want to ask this one is under the BCD value. When the BCD value is supposed to be on hash, right?
Yeah. So we use the hexadecimal.
Hash is a BCD value.
Yeah, no, hexa and BCD are same. But hexadecimal will have the alphabets A to F. BCD won't have the alphabets. That's the thing. So if you want to monitor hexa or BCD, you must use the hashtag. Decimal is the end symbol.
Decimal is an decimal, correct?
Yes. Okay, for BCD and hexadecimal, both use the hashtag.
Okay, yes, correct. So, yeah, you can see the actual.
Yes. Now, you see. Now the idea is, my motor is running, okay? When the temperature is 29 degree, I want to cut off. Correct?
Yeah.
Okay. Now, you see, I do comparison. Greater equal D24 hashtag 20. W0.0. Okay? Go to the SCL function. Okay, what is the temperature? 28, right? So let's say the temperature 29 means what number? You go up, all the way up. 29 means, okay, now 31. See, 29, what I get? So you click decimal, you uncheck this, the hexa, off the hexa. So 800. 860 something, right? It's too much floating. 60 lah. Let's assume 860 lah, okay? You see, I can do compare this one, or I can do compare 2981 and 860.
And 860.
Okay. 860 is what?
Is
860 is the analog value. Right.
analog value. Okay.
Okay, this okay, this one.
Analog value. Yes. Yes, it's an analog value, correct? Power
2000. This is the temperature. 0 to 100. 860 means it's a 29 degree. That what you understand? Okay. Now, you see, comparison, okay, you don't see that. Don't see that. We assume 860 means it's a 29 degree. You don't need to calculate this lah. Okay, just assume because around there only what 860, 870 and then okay. We assume 860 is a 29 degree. Now you see I can do comparison. This one also can, or this one also can. Okay, why? Because you see, 29 means is in what format? In temperature format, right? Right?
PC.
No, don't go for PC. I mean the value. What 29 means what? It's a Celsius, degree Celsius. Okay. It's a degree Celsius. And D24 also is a degree Celsius. So this one is in the analog format. Okay. So this one also will be in the analog format. Right? Okay. See, if I want to do a comparison, I don't need to do scaling. I can do this one also. Correct? Because at 2981, if I get 860, meaning it's a 29 degree. Correct? Okay. You understand that? Not clear, you let me know.
Still trying.
Which one do you understand?
Now is
This one you don't see. From here, which one you don't understand first?
now tonight was analog value. Is analog.
Address, not value, analog address.
Value from the analog.
Yeah, that's what I say. That's the thing. The terms you don't use that. 2981 is the address. Okay.
860 is the analog value.
The value, which is in 860 in analog. If in temperature is 29. That one you understand? Okay. Now, at address 2981, I get the analog values, which is 400 to 2000. Okay. It means 860 means if 29 degree means I will get 860. So here the range is from 400 to 2000. If I get 860 here, this workweek will on. Understand? The same thing here also. At D24, what is the range? Because at here, what is the range? Is that 400 to 2000. Here, what is the range? 0 to 100. Okay, what is the unit? Here is the Celsius. Here is the analog. We call it as a we call it as a raw value lah, digital value lah. Okay. Now, I can use this way to cut off motor, or I can use this one also to cut off motor. So understand? Okay. But which one do you prefer?
Degree Celsius.
Degree Celsius. Why? Understand? Because easy to understand. If anyone want to troubleshoot, when they see 29, even though there's no symbol, when you see 29, you can understand which is 29. Because for D24, you already put the name, temperature, so you can know. But 860, nobody will understand. So that is the reason we doing scaling actually. Actually, to do this comparison only we do the scaling. That's why.
To do comparison, need to do scaling first.
That's why I say not necessarily. You can do this way also can. This one also can. Both going to off my motor at 29 degree. So it's up to you. Whether you want to do scale, get the temperature value, because I can easily compare with 29, or I don't need to do scale, I just use the analog address, use the analog value. So now I have two options.
Okay. So because let's say I want to do the degree Celsius, I do the scale.
Yes.
If I go one, I can use the direct one.
Direct, this one also can, no problem.
I have to be clever smart.
Not clever smart. The thing is, you just need to you need to calculate your own lah to get what is 29 means is what at what address. That's all.
Which should normally
What then?
which normally you are practice.
Normally they will use this.
we also do this one.
Yes. So I said, so okay. Okay, let's say for example, okay, there's a project. Say this one, so I start motor on at 29 degree, motor cut off. Okay. Now I don't have any HMI, nothing. I don't want to show the temperature value anywhere. Just cut off. 29 is always fixed, right? I don't need to do scaling. I just calculate myself, or I just go to Google. I just type in, okay, if my analog value is 400 to 2000, and I want to convert from 0 to 100. If the temperature is 29 degree, what is the value? Then Google can give you the value. Okay? Then just take the value, do this one, cut off.
Oh, like that. Unless they have unless the is median from the zero plus T is zero.
No, just key in all this data, you can calculate for you. Go Google or the AI can do for you. Just need to tell properly lah. Okay? The y-axis very simple. The x-axis minimum is this one, maximum is this one. Y-axis is 0, maximum is 100. So if at y-axis is 29, what is the x-axis value? Of course, it can be used. Just normal calculation. Or you can use your own calculation, y equal to mx plus. Once you calculate, you will get this number. Then I just 2981860 again. Okay? Now I have a HMI. I want to show the temperature value. So for that I need to do scaling. Then in the HMI also, let's say this one can be always changed. Sometime 29, sometime 30. So what I do, instead of using this, I use a D10 or D20, any number. Then the D10 I put in the HMI. So they can key in degrees Celsius. So that is the scaling function. So actually for these two things only, one is to show in the HMI what is your instrument value. It can be temperature, pressure, whatever, to show what is the value and to do comparison. Only these two. Or sometimes you can use that for calculation also can.
So that another one straightforward lah, but
Yes.
you will big struggle.
Of course.
Then you find out the answer of the analog.
Yes, when you find out the answer, you can do this. But normally, if you ask me, the practical way is this one lah. Do a comparison better. Because why? They already have the SCL function.
The comparisons means that all is more than, less than, plus,
Yes, yes.
equal.
What
What other things that?
Yeah, symbol. You put a symbol.
So all these considered as comparison.
Yeah. But all these are only for greater than or greater than equal. This is for the, I think D is for what? You go down, you just mouse down. I don't know, the arrow down. Back, delete. Arrow down. Okay, this one is a string. Down, this one is a string. Go down. Double floating. Okay. This is a calendar. So you can use the calendar value. This is a normal floating. This is a long. Long means double integer. Sine. This one is for sine. The D is for the double floating. Oh, so many. Okay. So the symbol actually got so many symbols. Like this, greater, equal, less than, equal, not equal. For 6 times. And for each type, they have different type, right? Integer, double integer, which is called long, floating point, and also the additional for the what? Sine value, okay, and the calendar. So it depends on what Is it a double integer or is it an integer? Okay. Or is it a calendar? Then you can use the calendar, create a fault. Let's say you fix, it's when all happen. Let's say today you commission a machine. Let's say after 5 months you want to stop the machine. So they can call you, you can go and repair. Something like that. Just put the comparison, the date. So when you want to stop the system, do a compare, then stop the system. This one happened before, but not this way. There's one time one machine in the picture, they do car timing that. So during COVID, the first COVID 2020, right? 2020 near to August to September sometime. So that time all we can can travel, one person in the car, like that, right? Okay. So we start because during COVID time we might be closed. I do only online trainings. Okay. Then I think for the first 4 months nothing lah. After that online training. Then after that, this guy called me. So I go there. So it's a Siemens. So I try to back up like yesterday. What is that? Cannot upload. So what password? So I request for the password. He said don't have the password. Okay, never mind. I say okay. At least you give me the project file. I can open in my laptop lah. So he give me the project file and he put the task protection. Okay, not for all some, because Siemens you can no need to put all block to password. Some block you can put password. So I and my boss just open the program, do simulation, not with the PLC, do simulation because the actual cannot go online because of password and everything like that. So I go then. They have a system. They have a 2 roller. At the center there's one bar. So on top there's one roller, on the bottom one roller. So the rubber will go inside like this, on top or at the bottom. So before they start the machine, the roller they need to adjust. So they have a push button to adjust up and down and okay. Then they have the 7 segment display, the number display right. So they have everything. So now the problem is one of the roller, I think roller 1 or roller 2 is not moving. So the machine from China, of course from China they cannot come that time, COVID right, so they call us, I go. So since password cannot back up. So when I go through there, because I already know what is the output for the roller to move right. Then I see like a block like a SCL, right? Like it's not SCL, SCL is a block. In Siemens or here, so they can see function blocks, right? You can create your own blocks. Means inside the block is your own logic. Means let's say I have a logic that is repeating 2 or 3 times. Means I do one logic, make it into a block. The block multiple times I can use. Okay, so that's a program. So they have 2 blocks, one for roller 1, one for roller 2. So when I see, then I manually on off because it's just very simple. A block, input, output, that's all. So when the input output, I just play with the input output. I mean the inputs, the output all can put for both. Then I see at the block number 1 or number 2, there's a value keep on changing every 10 seconds. The other block not changing. Okay, because there's an internal program lah. So I try to open the block, cannot open password. Okay, so what happened is it means they put some counter which is every 10 seconds count 1, 2, 3. Then I say all okay, and suddenly I suspect, you know why? The block that counting is the roller in the physical is not working. Then I try to change the value 999, nothing. Then I put 99999, nothing. Then when I put 999,000, then 999,000, suddenly all the output off. So it means they put a counter when you reach certain value, all your output off. But I'm not sure whether the value is 9. They use counter and also comparison. Okay. So I don't know whether they use 999 or number any number. I don't know. I'm not sure. Then I suspect 999. Then every 10 seconds 1. So I just calculate. I get around 110 or 108 days. Okay. If the machine is 24/7 run, then I call the engineer. I ask, this one happened before or not? He said this is the first time. Then I say, every day how long you power on the system? He said, for 1 week, 3 to 4 days they will run the machine, and per day also 4 to 5 hours. So if you roughly calculate, I can go up to 2 years. Okay. Then they say the machine they buy already 2 years plus, there is no problem with this. So then I explained to this guy. They simply put a counter so that once the counter reaches certain value, you cannot move the roller, so you cannot operate the system. So of course you need to call them. So I have already told this guy, right? So this guy contacted the machine maker from China. They say they cannot give the password. They say they only can come, but they want to run. So what I did is, because the program is, the system is very simple, the roller movement. Because to move the roller, there are 4 outputs. So means, let's say input 1 and 2 on, output 1 on. Input 1 and 3 on, output 2 on, something like that. So what I do, I take out all the output cable from here, go to the relay. From the relay only go to the motor to move. So from the PLC to the relay, right, I remove the cable. Then I create my own box with the switch and everything. I do just cable according to how you want, because you already told me switch 1, switch 2 on, relay 1 must on, switch 2, switch 3 on, relay 2 on, something like that. So I do wiring according to that. Then I just put a small box because they have a split panel. That's where they have a roller 1 control, roller 2 control. Now one of the roller not working has roller 1 example. So I put a small box there. So now they can use my button to move the roller. Because the roller movement is just a manual only. Once you set to the value, after that just press start, it can go.
So when you said the password is actually just they want to come for service now.
Yes.
Then they will charge you.
Yes.
Smart.
But you know what? I tell them, okay, temporarily I put the box. Okay. So now with COVID, because that time 2020 or we don't know what's going to happen, correct? When the COVID going. Then I say, okay, I put ready. Let's say once they come back ready, then it's very easy. The output you take out the relay cable You take out the relay cables, then you connect back the output cables. Because now the relay is from my box Then he said okay. Then after that no contact. Few months back, there's a new engineer coming. He saw the box I modified. Okay. Then the other roller also got problem something. Then he contacted the old engineer. Old engineer say I am the one who do the box, right? He contacted me. Then he said this is the one last time you fixed. I thought they're still using the box. And I said yes, last time they say the other roller also got problem. Say can I come? I say yeah. I say I can come. Let me know when you want to come. But I tell them this one you should have removed one, because this one was old one. You should have asked for the password or remove something, right? And after that no contact. Means they're still using the box. The box I created.
Because one day, just same like if in my position, I need to contact them because if the machine can use.
Machine can run, it's okay.
Yeah, the company also don't want to pay for the expenses.
Yes. That's the thing. Okay, good. Any question that I want?
So far, what we learned about new functions, I noticed to set the value, to set the constant before value constant.
Not exactly to set the value. The main idea of move is move one data to another data. That's all.
Yeah. When you have data there, but it set it.
But what we are doing in the SCL is actually we are setting value lah. Okay. No SCL. Okay, because we cannot go and set value at T20, right? So we want something like always fixed.
Yes,
So
always fixed.
yeah, move this value to here lah. Okay. But some cases not like this. Some cases we just move the value to read the value or something to show in the HMI. So for example, let's say I want to show this number in the HMI.
So you can't W something, right?
Not necessarily. Can you see also?
W is an input for the machine.
Not necessarily. Can you see? Let's say for example, I want to monitor this channel 2981. What is the value inside here? I want to show in the HMI. For example, I can't show because in the HMI, the channel I think maximum 200 plus only. Cannot go up to 2000 for channel lah. So what I do, I move this value into another data register. Then that data register I show in the HMI. So that will be not set value, correct? It's just moving. Then so here is I'm setting values. This move function lah, I'm setting values. In that case, it's not set values. I'm just moving the value.
For example, this one is HMI. You say they have a limited channel also, right?
Yeah.
How
They
to
can
know-
show.
How to know there how many channels?
No, it's not limited channel. Okay, you go to the memory. You click channel. You go and see how many channels.
Oh, you mean the PLC channel?
Yeah,
6,000.
6,043, 6140 lah. But if you see in the NB designer, you close this. I don't think so can go up to that. You open NB designer. Yes. You put the PT. NB this one. No, 01 this one. Right hand. Oh no, new project, new, yes. Day 4, right? Yeah. Okay, just add the position. Okay. Then go to the PLC, go to the click here. Wait. CP1L, okay, using Ethernet, huh? Okay, we're using Ethernet. So our model can support CP1L, EM.
Oh, got different one. Internet.
This one is you go here, this one is a serial.
Serial.
Yeah, this one is a CP series Ethernet. Can you see? Yes.
Serial is means USB, right?
No, the RS232 port.
RS232.
Yes.
This one is the Internet.
Yes.
Or got different one. So depend. So means that let's say I choose already this under
CP1L.
the serial.
Also can use
Then I cannot use the
Ethernet.
internet.
So I must use the RS232 cable,
Yeah.
the serial cable lah to communicate. If you're using Ethernet, then I can use the Ethernet to communicate.
So I have to change. I have to define which.
Of course,
protocol.
yes, because it depends on what HMI and what protocol you want to use.
So let's say today I'm using this internet, but suddenly I want to change. So the protocol.
Need to change to the RS232.
Is it easy to change or?
No, it's easy to change, but need to do some settings. That's all.
Or I need to redesign everything?
No need to redesign. Can change. If it is changeable. it is easy to change, then okay. Then because if the same model you want to change the protocol, then no need to redesign, just change the protocol. What protocol? Whether you are using Ethernet or RS232 to communicate. Okay, the PT property is 10, right?
Yes.
Okay. Then you add the CP. Yes. Then you add the connector. You add Ethernet. Yes. Add HMI. Okay. 10. The HMI node address is 10. Node ID. Okay. The communication protocol is the CJ. Yeah, no. Okay. CPCP. CPCP is Ethernet. Okay. Okay. Right. You add another one, which is PLC. Which is PLC?
PD is the
HMI. PLC IP address is what? No, PLC is 1.
Yes.
Yes. HMI is the 10, right? 1.
This is supposed to be 10.
HMI is 10.
Oh yeah.
PC is 28.
28, right?
PC is 20.
This is 20.
No, this one PLC. PLC is 1. Okay, node ID 1. Node ID is the last number. Okay. So HMI is 25010, so the station number is 10. PLC is 251, this one 1.
Oh.
HMI no need to add.
No, it's PC, right?
No need. Okay, clear. Okay. Yes. So it's using the Ethernet, yeah, at this side. Okay. Now go to the HMI. Yeah. Go to number display. Read address, okay. No. This one is a see. I want to monitor this. I want to see can 2981 can wait. Click it. Go down all the way down to channel. No, this is counter. Go up. CIO. Yes. You put it here. 2981. It's a binary here. Leave it a binary. Okay.
It's not PC.
Because our 2981 is a binary number. Our analog or binary number. Okay. Okay. Means the range can use. So I can show. I don't need to move. If the range cannot use, then I need to use the move function. Just put it. Yes. Just compile and download. PC can go. Tools. Compile. Okay. Download. Transmission setting. You go to transmission setting. Choose Ethernet. Okay. This one the HMI.
This one is to HMI, this one.
Yes, the HMI IP address. HMI IP address is 10. Okay. So you have to transfer to the HMI because all these three connected using Ethernet. Correct? Okay. Tools. Download. Compile it, yes, because do something. you see got value or not? Here value. HMI.
85483 something.
85.
800 something.
Oh, okay, got 3 values right. No, just want to know. So it means correct lah. You can see the values.
Consider value for analog value.
Analog value, not a temperature value. If you want a temperature value, D20.
D24.
Yes, you do what? You put it here. Okay, so D24. Okay, what is the format?
Okay, let me see. This one is PC.
Yes. Okay. Compile, download it. But if you choose binary, then it will show wrong value, right?
If I want to transfer the file from this my PLC, I just put transfer from PLC, right?
Yes, ma'am. But I need to online first.
And designer.
Same thing. Go to tools, upload. Last one. Upload, yes. So first thing is here need to set first. Then what is the address? HMI address.
HMI address.
Okay. So what you want to upload? Project means all that. So just upload logo, upload recipe means one by one. All. So all means project upload.
To set the password for same,
Set password for HMI. Go to system manager. Yes. output. It's the same thing, just the position only different. The XY position only different.
Input. But input, this one is receiving.
Yeah, receiving. The output is you can control the motor speed or
I will send you the robot image.
yeah, the installation cannot write Excel.
Parkour, you don't have parkour section. No, it's not.
This one the one I sent you.
Yes. For example, this one is required. Animation is in the so this not considered as a channel, right? This considered as a big, right?
Yeah,
Big. And this one is only one big, right?
no.
Because you say it's using 32 bit.
Mm.
So this one is actually running 32 bits, just only one bit. But 32 bit is only this one. For in and out lah. Yeah, it's 32. So it's 32 bit of in and out.
This one 32
Yes, correct.
because for the value lah.
Yeah,
For just on and off the signal, just they just use some bits on it.
some bit of it. This is not a channel. This is only one bit.
Yeah, one bit.
So really said this one is only two channel enough.
Yeah.
Yeah, two channel. One channel 16 bit.
Yeah.
So
So
consider two channel.
two channel.
Okay, that's good. Interesting is very important. PLC.
Yes.
If you're not clearly. But
It's
it's
the
the
same
same
feature.
feature. Understand.
Interesting is very important. Because you need to know what address you want to take, you want to read.
Only big and turn on and off.
Physical dia boleh test.
I'm not sure. Is it installed? Can you? I'm not sure. This one you using that one to install. Is that I need to install this one or need to install the other side? So you said you're using the file inside there to install it.
The file inside.
Exactly.
No, but so UGT, all these are models, the HMI models. Okay. Not the same, all the HMI models. Tellers means the tellers. Opening the tellers. Okay, means no, tellers means it cannot transfer to HMI. Only can open using this. So you can only your laptop only.
Oh, it's just like a HMI on the like a simulation.
Yes, like a simulation, but it's a runtime. They call runtime. The other models, yes, you can use for the transfer. But this one, you know why I like to use the VSLT. You can choose the parts like this. Okay, and the settings lah, right? And style similar lah, right? And they have another function called visit. Visit means it can bring you step by step. So it asks you to choose the lamp first. Next, you have to choose the how you want to style, right? Next, then only ask you to choose the each channel. You can bring you step by step. So only VSLT 5 only left. 6 don't have already. 6 is the new version of the 5.
But this is new version 6.5 or something.
It depends on the model. This one the model. Yeah. Running on a trial period. Okay. So it runs 1 hour only. After 1 hour, it open again.
Oh, okay. Only tell us that. Then you see that CP1L is better option, right? They have option for
Yes, actually CP1E also got.
zero got is the plot.
Oh, CP1E. This because this one is a CP1E.
They have a
Serial port, but option don't have option board, right?
Yeah.
Because this one is the CP1E and 40S.
As is
Oh, this one don't have. This one is just N40 only.
N40.
It's the same thing. No, I think it's an N30. 30 I hold. This one is N30, no S. So this one got option board. Can add the option board.
Okay. Com. This one have. This one is a serial port, USB port. Again, just like you mentioned about this one got a small button on, off, on, from.
I don't know, I'm not sure.
Oh, let me change it. Okay. Okay, condition A is minus, B is plus. Now I better understanding about machine. Better understanding about cable wiring communication.
Yeah.
toolbars.
The auto scan.
Your PLC you will connect power.
Yeah.
And you got control.
So how is according. Disconnect. There again is PSFT. I want to change the communication. Double click here. Double click the satellite. You can change the communication. Here is SysMac.
SysMac is
The RS232 port. This port is called Omron, they call SysMac. This is SysMac way, right? So if tellers want to use, then I can use, because RS232 only one software only can use. So what I do, go and change USB. So now connecting USB. Okay. USB connected. Tellers is complete. That is this one. Okay.
this one called
USB. So it's a USB.
okay.
That is can work. Ini tellers can work lah. I mean it's hot. Because it's a different port, right? That's why.
Different port. They are all using that one also RS2.
RS2 but the rating all different. Because this one is using 9600. Work only the setting change.
What is the setting for this one?
No, now data integration. That's now this testing. Now what we do? Somatic sector. When we do the HACO and now we PLC alarm. Specific alarm. Right.
What alarm?
This is a system alarm. Okay. What do you want this one? Right. It's a
Yes,
resolution. If you see alarm, change back to Ethernet. It's now try it. Port. Can work or not? Can work. Okay. go to analog. So option board error. This one lah. Error. Not just now. Connect and I take out right. This one. So clear. That's okay.
The error come from this
Error. Error. Yes. ERR error. Okay. So it's okay. Now we continue with the output.
Output. Okay.
Analog output. So
Okay.
analog output, how do you want to do? So for now, because we cannot have need to connect to motor, then only we can know this. Okay. But for now, what we can do, we can measure the voltage. It's the voltage, right? Because our output is a voltage only. Input can be voltage or current. Then we can put to DC and just plus minus. Just check. For now, nothing lah, right? Because no program. Later once we done the program, then we can get the value.
So you're using the voltage to control.
Voltage to measure whether there is an output or not. Then this voltage later we can connect to motor to control. Okay. So what I want you to do is try to do this. But I will do the graph first. Okay.
But just now you show 11 voltage was also quite value, right?
But that one is in millivolts.
Just very small.
Yes. So means that small. Now we need to know how the output work. Okay. What is the output address? We have two output, right?
Yes.
A01, A02. What is the address? 2985.
Sorry, 2985.
Right?
2986.
Okay. So how the output work? Output is this way. From the CPU, you need to send the signal to the AO card. That is 0 to 4000. Which is 0 to 10 volt, right? Then here you can connect to anything. Okay. So let's say it's an inverter lah. Let's say a motor or tank. Okay. Let's say 0 to 100%. Want to see the full speed lah, right? Now, so the thing is very simple. Okay, you see how the analog input work.
How do I?
How the analog input? See analog input. It will measure the temperature, convert into analog signal. The analog signal I connect to PLC. I will get the digital signal. That is 0 to 4000. Then later, 0 to 4000 I convert into the engineering unit. Pressure, temperature, right? But for the output, the PLC need to set the value. You need to give the value. Means you must have a set point. The set point later you send out into this value 0 to 4000. Then when you measure at the analog output, you will get this data 0 to 10. Then when you connect to inverter, the inverter can run 0 to 100%. So the graph will be like this. Now different, okay, you see. Now here will be your set point, your x-axis, which is 0 to 100%. Then this one will be your analog out. Which is 0 to 4000. Okay. Means this one will be in a D lah, you need to key in value. Earlier the X is you receive the value, you convert into Y. Now the X you need to key in value. The output will be your analog. Okay. So you try to do. You add one more section. Try to do one. So it's up to you. You want to use the SCL or you want to use the calculation? It's up to you. Which one you want to use?
Using the same formula.
Yes, same formula. Only the Y and X is different now.
So output is analog will be of the X
Yeah, Y.
or Y.
Yeah.
So we want to find a set point now.
No, we need to give the set point. We want to find out what is the output.
The output.
The same formula.
But it's an analog output.
Yes.
Okay.
So means, okay, for example, you key in 100%. So at 2985 must be 4000. Then when you measure the voltage, you must get 10 volt.
So now my question now is I need to find out the analog output.
Yes, correct. Means from the if you mean how to say, if you use the same concept, okay. Earlier we get analog input, we want to find out the temperature. Right. Same concept. But now we set the input. Then the output will go to the analog. You try and see.
Okay, I try to say. But I just want to understand the logic first.
Yes.
like, I don't know, today, this one, yesterday, yes, yesterday, yes. Today, no. Find you again, no. Yeah. What is the amount? Yeah. This one is the what? This one will be the flight ticket. Yeah. Yeah. Six, yeah. Yeah, this is the one I noticed. That's very cool. I don't know what's that. Yeah. Yeah. Okay. Huge. suddenly got a hack my credit card. So I received a notification, please the transaction from a USD. I quickly call back to block the card.
Last time happened for me. Is the transaction when they take the money or
Yeah, the transactions from credit spend and credit card.
how much they spend?
3 transactions. Morning 5. They start on 4. They try the card by 0 1, and after that one amount for about 400 something USD. Then after that another amount. I haven't checked. Then before around 2 they try another transaction. So that's why, because body I didn't know about notification easy. So now I think I can't go to bank transaction. So I check.
Same thing last time happened.
And this is not the first time already.
Oh, for you.
Yeah, not the first time.
How they take all the card details.
Yeah, how they take the card.
So I was saying, suddenly I see luckily normally when I get message that I would see.
Yeah.
Suddenly I see used in USD. No, used in USD. Some what name? It's like a bike store. Like a bike store. Then I check the card with me. Right. Then I go to Google and see where's the bike store. It's in Australia or something. Then it's but very less amount, much around $20 something. Straight away, one day the transaction is done. Another one you try to pay another thing lah. Then straight away call back, block everything. Then they think within how many days they refund. That's why I'm always scared to. So yeah, whatever I always the limit all I will always keep low limits.
Not timely. So I need to call back, otherwise I don't know what going to happen.
Yeah, you need to call straight away block first. You done already the block?
Done already. Okay, now what can I do? Let's do structure for this. First you need to set up, you need to write down all the IT requirements.
Yeah, you take note first.
Input,
Yes.
parameter and refund.
Yes.
So SLC, SCL always have to input parameter and result, right?
Yeah. Click in a new section, huh?
Yeah, session.
Yes. Click.
Like for example, you are because of the program, you need to write down all this in the paper, and all this. What is the point? Otherwise, when you write program, you should collect the program.
Yeah, that's right.
Right?
Sure, kalau you need to
Write
write down.
down. You need to write
That's why
down.
normally when I write down, I ask them, okay, want to take picture or not? Whatever I explain sometimes.
No, I mean as yourself. As yourself, you
No, last time, yes, last time I do that. Then when you do practice, right, every day use PLC. You get used to already, so you know. If you forget, also you know where to go and search.
I just worry I can't remember. the parameters 1, 2, 3, 4 is actually start from Y first. Minimum
Yes.
away from Y first.
Always yes.
Even go for output also same.
Same. Yes. The form that's why I said the SCL function is simple. They use Y, Yx, Yx. Okay? But the way we write the program, I mean the way I do the graph is different. X and Y is different.
But now the analog output, the AO1 become binary. Because you will see the Y
Okay, very simple. For the SCL function, they have a graph. This is the x-axis. This is the y-axis. So x-axis is in binary. Y-axis is in BCD. So x minimum, x maximum, y minimum, y maximum, right? Okay, this is the graph.
this is for input.
No, input or output, this is the graph.
Even binary BCD also same.
Same thing.
But now the output of analog is on the out. So and the analog will become BCD, right?
Yes.
It's not.
So it's not correct, right? So you need to convert BCD to binary.
Convert BCD to binary.
Yes.
Later.
Later.
Okay, so still BCD.
Still BCD. So means this is the graph. SCL, the x-axis, the first parameter, the y-axis. So this is the SCL function. So I don't care how the graph looks. So this is the function. So when I do the graph, okay, for analog input, x-axis will be in analog input, y-axis will be the memory, right? The D. For output, x-axis will be the D set point, y-axis will be the analog output. So the formula is same. So like you said, so now this one, because this is binary, right? And this is BCD.
Yeah.
And we know analog cannot be BCD. Right, so what you have to do? So SCL, of course for set point I use any data register. So what data register you use? Oh, you haven't do, right? Okay. So any data register. Because I need to key in the value. So let's say D30, D31, the first parameter. So parameter is, so then the result must be 2985. That is right. But of course now 2985 cannot use here because it's a BCD. So now I need to see. So 30, 31. Inside here 31, 32, 33, 34. What for, right? Inside here. 4 parameter. So next available is 35, right?
Yes.
So we do this first. Then the 30. You need to move the value, right? You need to move the values, correct? 31, 32, 33. Then later on, use a function called binary. Then D35 convert to 2985. This is a function called binary. This function will convert BCD to, we call 16-bit line.
You use this binary function.
Yes, it will convert the BCD to 16-bit. 16-bit is actually binary line.
This one I haven't used, right?
We haven't used.
Okay.
It's a new thing. Okay.
Good.
But never mind. The thing is, you understand there's a BCD binary, all that, right? That is important. Okay, so the x remain x, while the remain this formula all remain the same. Only the position when you do x and y is different.
Okay. Bagus. Yeah.
You need to key in 0 to 100% and D30. Then you can measure that analog output. Move 0 to 31, right?
Yeah.
Right, okay, go down. Move 0 to 32, okay, go down. Y max, okay, 4000, correct? Then 100 to 34 is correct. But the value is haven't moved here, correct?
Yeah.
It means what? You haven't downloaded yet. Haven't transferred yet. Transfer. Online. Can close this. Okay, so D31, okay, 32. Now at D30, you add one, add a B, right? D30 is your X, right? Is the set point. D30, then use integer. D30, integer. ING. Okay. See here. So D30 is your set point. Okay, means this is where you key in value.
D30 is my set point. Yeah, for X. Correct.
X axis lah, right? So it be in binary. Correct.
This is a binary, right?
Okay, so that's why I asked you to put integer. Okay. Okay, now you key in 50. For example, 50. Okay. So it means if you key in 50, you should get 2000. Okay. Go down.
2000 BCD.
BCD there, right? Okay.
Correct.
Correct. Because you see, you understand this. I put 50, I get 2000 BCD.
Correct.
Okay, go down. Okay, so you haven't do the conversion yet, right? This one done, not yet.
Not yet.
Okay. Now, so at D35, you see, at D35 already got 2000 BCD. Okay? You know why I cannot use 2981 straight away here? Okay. You click on the decimal. You see, BCD 2000 means in decimal or in binary is 8192, which is not the same thing. Understand? So that is the reason we need to do the conversion. Okay, you add, okay, you go offline. Okay, you add one always on. BIN. Yes. Delete. Backspace some. Okay, can you see? BCD to binary. Okay?
BCD to binary.
Yes. Okay, space. So first must be the BCD B35. Okay. Space. And the result must be 2985. AO, you put AO1 BCD. Okay, this one not set point, this is set point output AO1. Now download again.
So this one is set point. BCD. BCD. So BCD. Okay, now add one.
That's all.
That's all.
Okay. Now you see here in BCD 2000, binary is 2000 also. Okay. Now measure the output?
Measure the output. How to measure?
The voltage.
Output. This input.
Measure this.
Plus minus.
Yeah, this is plus minus. Yes. Okay. 5 volt. Right? Because why? Because you gain 50%.
Okay.
Correct.
Okay.
Okay. And if at 2985, so means measure program give 2000 to the output.
Okay.
When I measure, I will get 5 volt.
Okay. Because it's the 10. Because of 10. 10 is the maximum.
Yes.
The 10 is the maximum.
Don't forget about this. It's not understand. Because you gain 50%, correct?
50%.
And D30, right? 50%. Okay, now you gain 100%. Because that's what you're scaling is now.
So D30 is
Here, D30 is your set point now. So you gain 100%. What do you? No, you put 1000 wrong. Okay, what do you get? 4000. Right? It's a BCD, but I already converted 4000. Right? Okay, now imagine. Now I get 10 volt. Okay, so now if I take these two and connect to my motor, the motor will run 100%.
But here is only 10.
What's that?
Okay.
Okay, it's okay. I think
You think
you're confused.
100%. Set point is 100%. 100%, 50. But here, why here was only show 10?
Because your analog output is what is the range? What is the analog output range? No, your output is what? Analog output is what? 0 to 10 volt, right?
Analog input.
Analog output. It's 0 to 10 volt, correct?
How to measure? How to measure is 10?
Okay. Very good. Okay, now, okay. Now, okay, analog input. What type of analog input the PLC can bring?
What type of analog input can you? Analog input can you?
Analog input.
Binary.
No.
BCD.
No. Voltage and milliamp.
Correct.
That one you clear?
Yeah.
Okay. So this is the CPU. CPU means the my PLC. Okay. Then one analog input card. Then I have a transmitter. Then I have a instrument. It can be any instrument. Okay. So this transmitter, whatever the instrument, this transmitter will give 0 to 10 volt or 4 to 20 milliamp. Clear? That is the range. Cannot more than 10 volt. Same thing, cannot more than 20 milliamp. Okay. But what is my analog input, the job of this card? This card, the job is convert this analog value into digital values, which is 0 to 10 volt means it's a 0 to 4000, right? 4 to 20 means it's a 400 to 2000. Until here clear? Okay. The same thing for your You see the arrow, same thing for your output also. Now, this is the arrow output card, and this is any instrument, normally a inverter, the motor one, to control a motor. Okay. Now, the CPU need to give 0 to 10 volt or 4 to 20 milliamp. Okay. Then my analog, sorry. Okay. 0 to 4,400. Okay. You see, this is the normal, okay. But this is a common one. But it won't be more than 10 volt, won't be more than 20 milliamp. Then my analog output card will convert this into 0 to 10 volt, this into 4 to 20 milliamp. Clear? Until here? Clear? Now, this one connected to any motor or something. This one can be connected to any sensor. Okay? Okay? Okay. Now, you need to understand here. This is my CPU. Okay? You see, the CPU will receive these values only. Correct? These values. So, AI, so it can be 0 to 4,000, or I put 0 to 20 lah, okay? Then it is 0. So we know 0 to 20. Okay? Okay? So it can be 0 to 4,000 or 0 to 2,000. This one meaning 0 to 10 volt data. This one meaning 0 to 20 milliamp data. Okay? Then I want to convert to any unit. This is the engineering unit. Okay? This engineering unit based on the instrument we use. You got it? Clear until now? Any question?
So CPU. Okay.
Can I think if you see first, later you can take picture or take note. Okay? So until here, okay, clear. Okay. Now let's assume this is a pressure sensor. Let's say the pressure sensor shows that it can measure 0 to 30 bar. Okay? So what we do? It can be voltage input or milliamp input. Then change to 30. So it's a pressure bar. Okay. So now, and we know this is in, okay, when we do the scaling, right? BCD, this is in binary. Okay, so it means, so what we do, we use the SCL. So SA analog input, our analog input is 29801. So 2980, D0, it means D1, D2, D3, D4, then D5. This is our SCL function. Okay, okay. So this is our AI. We receive the AI, then Y min, X min, Y max, X max, press, you get the value, right? So you will use the value, right? Okay. So after I convert, I can do comparison. I can show in the HMI whatever I want to do. Okay. So any question on the analog input?
So means that I can use either is a voltage.
Yeah, you off the one. You make it off. Yeah, the one off. Okay. So I can use either voltage or milliamp.
Correct.
Yes, can. But depend on my instrument. Let's say the instrument says it's a pressure sensor 0 to 30 bar and the signal is 4 to 20 milliamp. So it's a 4 to 20 milliamp. If it, let's say it's a 0 to 10 volt, so it's a 0 to 10 volt. Or let's say it's a 0 to 20 milliamp, so it's a 0 to 20 milliamp. Okay?
Either way can use.
Yes. So
Let's say they need both.
both cannot. Only one instrument only can use either voltage or milliamp.
Okay.
Okay. Output. So any question on the input? No. Okay. Now the output. Output also the same thing. That is from the CPU. Now you see here you receive the value, right?
Yeah.
So here you receive. This is what you receive. Then I convert back to this unit, so I can show in the HMI. But output, how the output go? You need to give to the output. You need to means it's from the PLC out, like a digital output, right? Who on the output actually? The PLC is the one on the output, right? I receive the input, I on the output. Same conception. I receive the input, I send the output. But it's a value.
Output mostly is a motor.
Motor, anything that is motorized means motor, pump, blower, conveyors, mixer, valve, all that. Anything that is like a motor can rotate lah. Okay, good. Okay. Now, so when I want to do a graph, okay, so we know that always the x-axis is the one we call what? Variable. The one keep on changing. Right. So now in this case, this one will be depend on my what is I'm using here. Let's say it's a motor. Okay, so let's say it's 1,500 RPM. Okay, 1,500 RPM motor, right? So what I do, set point RPM. Okay, which is 0 to 1,500. Okay, then the output, the AO, okay, must be what number? 0 to 4,000, right? If it is my output is a voltage, let's say my output is a milliamp, is a 0 to 2,000. It's the same thing. But in our case, this the option board, right? Only F analog, the voltage only. Okay, that's why just now we use the 0 to 4,000. Okay. Now the same thing. This is the binary. This is the BCD. We cannot change this. Okay. Because why? Because we are using the SCL function. If you are using your own conversion, then it's no problem. Okay? Now my question is, how the output can send 10 volt?
How my output
Can send 10 volt to the inverter. So means the PLC need to give 4,000 to the output address. Correct? That's why just now we do. But you key 100%, it become 4000. 4000 means what is the voltage? 10 volt. That's why you get 10 volt just now. Okay? Now, so when you do SCL function, SCL, okay, this one additional, right? SCL function, let's say I start with D10. So D10, D11. So means D11, D12, D13, D14. Y min, Y max is value. The same thing, because that is the formula. X min, Y max, X max. Then D15, any number lah. But make sure you can use these numbers. Okay, now the D10 is what? D10 is my set point RPM. Okay, in this case, pressure the bar. Okay, then the D15 is my AO. Okay, my analog output. But since according to SCL function, this one is according the BCD binary is according to SCL function. If you are not using SCL function, so it's not BCD binary. It's like normal number, normal binary number both. Okay. So since using SCL, the output is the BCD number. So what we need to do, we need to use one more function called binary, which is convert the D15 into 2985. This is my AO. This is the AO in BCD. Actually, this one also, right? This D5 also, because this also is a BCD, right? Actually, you can convert to binary if you wanted to do that. Okay? If you wanted to do that, let's say all your program you want to use only binary numbers. Normal, right? Normally you use binary. So, if you want to do that, you can do the same thing for your D5. Okay? So, it's something like this. Binary D5 convert to D6. Because this is in BCD, this is in binary. So later want to use in the HMI, you can use the D6 in the HMI. Okay. So now you understand?
That's just okay.
Yeah, of course. Okay, of course. But the thing is, okay, always the people will confuse on which part, always the output they will confuse. Why they confuse? Because earlier when you do analog input, right, means like you get the value, so it's easy to understand. Okay, there's a temperature. Okay, I convert 4 to 20 milliamp, come to PLC as a 400 to 2000. I do the calculation and convert into a temperature. So you see the result. There is a temperature sensor in the PLC, also temperature. So you can see the result. But now the output you cannot imagine. That's why normally people confuse here. Because the output is you need to give out. Means you need to set point. Similar, actually the concept is similar like digital output. Okay, who on the output? The PLC is the one on the output. But who do the program? We are doing the program. We do it like, okay, if the input 1 is on, output 1 on. If input 2 is on, output 1 off. We do the program. Same concept here also. So we do the set point. We give the value. Like, okay, I want the motor run 1000 RPM. So I key in 1000. So I do the calculation. Then I will be somewhere 1000. Okay, let's say 750 now. Okay, half. Then become 2000, right? then 2000 means I will be 5 volt. When I send 5 volt to the inverter, the motor will run 750 volts. Got it?
Okay.
Ah.
So we will see, we will transfer how many voltage to the motor to run.
Yes.
Okay.
If you see this thing alone, right, is similar to your analog input. If you see this thing alone means if the inverter receive 0 to 10 volt, I will run the motor 0 to 1500 RPM. Because for inverter, this guy is the input. For the inverter, this is the analog input. So I get 0 to 10 volt, I run the motor full speed. Okay, good. Okay, so you take notes. Whatever you want to take note, take notes.
I need to draw some papers.
Yeah, of course. Okay. Okay, take a break first. After the break, we continue. So here we already done the compare, max, SCL, move, right?
Compare with,
Comparison?
compare what is compare?
The comparison. Greater than, less than,
Oh,
that's what comparison. Greater, less than, right? Equal, not equal. Okay.
the AI is actually the sensor. You want to read on the sensor response and to see the response whether you want to use the information for your not sure you want to use
Yeah, what you want to control. Yes.
Otherwise you just for reading or what's
Yes.
the temperature
Yes.
of the HMI.
Yes, correct.
Right. For the display purpose for the UI.
Yeah, yes.
And the output, yes, the one is another data. What is the data you want to control your conveyor?
Yes, correct.
The data maybe you set the value
Yes.
or from HMI control the value.
Yes,
That's the value you want to control. And send the data, do the calculation, send to the meter.
Same, correct.
That's why I confused.
Yeah, I know that this one I know where you confuse the curves in the part. Because what you do, this one normal, because what the normally participant think, like normally digital input, right? You get the input, then you straight away on the output.
Yeah.
So what they thought, analog also same thing.
Yeah.
You give the input, output also same. No, it's not, can, but depend on the program. What you want to control.
Always input is input.
Yeah.
Stereo input. Output
Yes.
stereo out.
Yes,
Don't
correct.
confuse if you go through the output.
Yes, correct.
Right?
Always input is different, output is different. It's how you want to control the system is based on the flow chart.
PLC is just helping you that you see the information, how you want to digest. And then you want to send the instruction, is go through the output.
Yes, exactly correct.
Right.
PLC, yes, correct. Like you said, PLC just receive the input, then how you want to control the output is based on the program. Whether you want to control from the digital input, or you want to control from the analog input, or you want to control from the touch screen, it depends on the program.
So you have, for example, this kind of control box.
Yeah.
You know the distance of what is the you can see
Yeah.
they have a certain kind of what kind of center distance. You have a guide,
No, there's no distance.
no distance.
No distance. It depends on, okay. Let's say for example, let the same thing. See here.
I noticed that all this time you have a certain distance.
I'm just reading. Last time we just put it there. Some places. It depends on what parts you want to connect there. See. For example, how do you call this again? It's a DIN rail.
Team rail.
DIN.
Can get from any hardware shop, right?
Hardware shop.
No.
Yes, can also. Because normally our DB right, the distribution right, I want to use the same thing. Electrical shop.
But they have a certain standard because otherwise your
No, it's normally the same size. Yes. say this is the panel. Okay, I don't have this one. I just put the cover lah. Okay, that's it. Now we put it here. Next, so normally on top the PLC. Okay, but some whatever is on top they put all the MCBs. So it depends on how they want to design. There's no standard there. But normally, if you want to go follow good practice, on top is the MCB lah. Okay, so when you connect MCB, let's say I put it here. Let me just connect MCB. The distance, make sure the cable, I can connect the cable. Put the cable connect this. The distance is not a problem. Okay, it can be here or here, no problem. But make sure how big is the panel lah. If it is enough space, okay. So let's say this is my panel lah, example. So I put it here. So let's say this side just nice, okay. Then on the second, put a PLC. So same thing. So make sure the cable, because the trunking will be like this, right? So make sure the cable can go in. And another trunking here. And another D-drill. So this D-drill, okay, I want to put a relay. I want to put some relay, some terminal blocks. Okay, for this terminal block and relay, until here enough. So this is enough, right? Until here enough, right? This space enough, right? Just nice.
This is the confirmation.
Yeah. Supposed to be. This one is just the down cover, lah. Okay. So this like this enough, right? So let's say I have so much space, then okay, maybe I can put something. This make some space lah, right? Okay. So let's say just nice like this. Okay. Now, let's say this is normal terminal block 1 to 1. This terminal block is a special one. That is, here connect the positive. Let's say you want to use the 3-wire one. 3-wire one. Okay. So here is the positive. So what I do, I will connect like this. Okay.
But this one, everything is separate, right?
Yeah, everything separated. Okay. So normally what we do.
How you call this down? This is separate, this one is
Just no, this one is separate. I just use a link to connect.
Oh, you have relay.
Yes. I can take out the link.
No, the link can be taken out.
Yeah. Just a screw.
But they are all sharing the same.
Yeah, if I connect means all sharing the same signal lah. Okay. So now you see. Can you see there's a hole here? So there will be a connector like this. Something connector like this. So there will be a special connector lah. So means all are linked. So all are linked. At the end they will connect a 0. Means all the blue color will have a 0. So then red color also same. Here also same. Here also they need to connect something like this, a link. All the red color will have a 24. Okay. Then this is the signal. That is from here to here. Okay. So let's say this is a 3-wire sensor. 3-wire sensor will have what? Positive, negative, signal. So the positive they connect here.
Positive.
The red color. Then the negative connect here. The signal will connect here. So the signal actually, this one is from the input. signal.
I see
So
got 2 cable.
there's 3 cable.
1, 2, 3.
1 to 3.
This one?
Yeah, this one. Okay.
Or this either one.
No, not either one. Okay. This one is all for the power.
Yeah, power.
This one is like this one is exactly same like this one to one. This side from the PLC to here.
Okay.
This one from the field.
Oh,
I
okay,
connect
okay,
here.
okay.
So the cable management will be nice. If I use like this, right? So I have 3 cable, right? So it means here like this. So one go to positive, one go to negative, another one go to the input. So this one will be bigger. If I do this one, it's just only one block can cover all the 3. If no, I need 3 terminal block like this. Okay. So in this case, I need to give some space. If I'm using this type. If I'm using only this, then I just need spacing. This one also same thing like this, but double deck. Double deck. So the space arrangement is not an issue. So where you want to put like that, right? So like that, what happen is on top, plus they have all the MCB, because this one I take from the company machine. Okay? So
Why they have this?
they put this way to save space. Yes. So what they do here actually was here is they put all the MCB. Okay. Then here is the terminal blocks. Okay. Here they put the PLC. Because if they put the PLC here, then not enough space here. So they put the PLC this way. All the PLC input output they connect here. All the input they connect here, all the output connect here, and here all the what? The contactors.
Contactors like
To control the motor. Similar to relay. Okay. Then so the PLC wiring will be inside here. So from the field, from down will come out the cable, right? So all the cable will go to the terminal blocks here. Because this terminal block already connected to the PLC. So it's just they have a small space, they do like this.
This one look like
This one is MCB. This one is the contactor. This one is a relay for the contactor. So when our company want to throw, they give it to us when I see when there was some terminal blocks, one PLC here. Another type of terminal blocks.
it's a relay connector.
Relay.
How to break on the relay?
Okay. Now you can take out this. See the relay. So this is the relay base with the number. Can you see the numbers? Okay. So now you see on the relay there's a 13, 14. Here down here. 13, 14, right? Or A1, A2 lah. Some country they use A1, A2, some country 13, 14. So this one is a German one, so they put both the number. Because in Europe all they use the A1, A2. Take a picture. So the A1 into lah, down here, right? Okay, so but the number here is the 13 outside of the bracket. Inside the bracket is the Europe style. Outside the bracket is normally the Asia Japanese style. Numbers.
Inside the bracket is
Europe
outside.
is a Japanese one. Only Omron all they use the number only. Okay, good. So what is the function of the relay? 13, 14 or A1, A2, right, is the coil. Means it will energize the relay. Okay. Then can you see here? Inside here, there's a magnet.
Yeah.
So normally open, normally close functions. So therefore 4. Okay. So you can see the number 11 inside the bracket is number 9. Sorry, number 9 and 1 is a normally close. Number 9 and 5 is normally open. So what happens normally, signal will connect to number 9 and this one go to your device. So when you energize this, it become
This one like a plus minus.
plus minus. So when you energize this one become close. So the device can go. The number so here is exactly here.
So this is the number 12, 10, 9, 10, 11, 12, 9, 10, 9, 10, 11, 12.
Yes. This one okay. The 13, 14 is the coil. Okay. 13, 14 here.
Okay.
Then 9, 10, 11, 12 is this side.
Okay.
Then here is the 8, 5, 5,
8, 5, 6, 7.
8, 5, 6, 7 is normally open. 1, 2, 3, 4 here. So it's normally closed. Okay. Why they use relay? Okay, you can see here there's a coil, right? Something 24 volt DC, and like a contact is a AC. AC. It means to activate the coil you need a DC voltage, 24 volt. But the cable that running through this normally open, normally closed signal can be AC. Okay. So let's example. Your PLC is a transistor output. Okay, and 0 or 24 lah, transistor output. And my device, let's say a lamp, is a 230 lamp. So of course directly from my output cannot go to the lamp. Right. So what I do, the output energize the relay. Relay can supply the 230 to my lamp.
So I just correct from NCB 240 connect to the
Here,
normally
the common, then the normally open go to the lamp.
then let's say connect to the common, the rest will be the plus of the right.
No, and all separate, individual.
Individual.
Yes.
Okay. This considered
Yes.
individual.
Yes.
So if let's say I want to connect, so all is connect to plus.
If you want to use the 4 contacts, then all plus. So maybe the first one you want to use 230, second one you want to use 24. Okay, no problem. So the function of the relay is switch on something where my PLC cannot do directly. So I need the relay. The same concept, the contactor. Yes, contactor also same thing, but they only have 3 contacts, which is only normally open contact. This one is normally open, normally closed. Normally is normally open contact, which is directly connect to the motor. This motor will have a 3 cable.
They are not relay, right?
That's not a relay. It's a they call contactor. But the concept is the same thing. But they only have normally open contact. This one normally closed. Normally open or normally closed contact. That one normally open contact. So you and then the contactor also will have a coil. Yes. You energize the coil. The 3 live cable go to the motor to run the motor. So this is the inverter. Just now you talk about inverter, right? This is the inverter.
You wanted to control the RPM.
Yeah, motor speed.
You see,
Okay, very simple.
this cable is the ground, which is a line power cable is power supply.
No, this is go to here. This is the UVW 3 cable.
This is the power, right?
No, power is beside. Using L1, L2. I haven't marked it. So L1, L2 to power up this. Then the 3 wire will go to here to power on this to run the motor. Okay. Why are we using this? Actually, the contactor also directly can connect here. But if I using contactor, means contactor will give full power, full voltage. So this one will run full speed. But if this one means I connect the power here, power up here, so the PLC can send the signal here, then to control, then here I can set the value how much I want to control. Or there's a three-way to control the inverter. One is I set the speed here, then PLC just send on-off signal. Second one is the PLC, the analog output connect here, so the PLC can control the speed. Third one is using communication. It's a three-type of control.
This is right.
It's just a ground. It's to protect, like, if anything short means that's why the grounding is there.
But they are not using the grounding here.
No. It's just supposed to be different colors lah. I only have this cable, that's why I just use this cable.
This is not power.
No, actually not the power.
No,
is-
not the plus minus.
No. This one is just to, they call L1, L2, L3 or UBW. It's supposed to be RYB, red, yellow, blue color. But I don't have the color, I just use the normal cable.
So for this one RPM, output, okay, set point here. So using the set point here instead of using the HMI.
No, means if I'm using set point here means I just set value here. If I want the PLC to set, is the analog output.
There is an
Output, then from the HMI or from my program, I can control the speed.
But this one how you this okay sorry. So for example for if let's say
You want to control this way,
we
okay?
use an HMI controller and
Yes.
improve.
Yes.
But this one different. We can't use using the direct connect to this one to control the motor, right? This one is direct just control,
Yeah, direct control, yes.
not going through the PLC.
Okay, there's a three-way to control, that's the thing. Three-way. One is just control the speed here. Means just set the speed. You can use this potentiometer, set the speed. Then you PLC just send on-off signal here. The motor will on-off. The speed control here. That's the number.
That no need go through the
No need analog. No
okay,
analog.
okay.
So it means the speed is always fixed lah.
Yeah.
They won't change. If you want to control the speed, let's say when the temperature increase, want to increase the speed. In that case, I must use analog. So the analog give is here, then the motor will run according to what is your analog value.
So this one is using. Can I say this one is using the Internet protocol?
No. RS485.
R8.
RS485.
RS485.
Yeah.
Where is the
head they use this.
the head is
The connector they use this. The RJ45 type connector.
okay.
But the protocol is not Ethernet. It's a 485 protocol.
R8.
Yes, RS485.
R845.
The 2-wire one. On that. I have the cable here.
RS485 is this one.
Let's use this cable. So this one connect here. But you need to check the manual lah for the pin. So got 8 pin. So they will tell you need to use the resistor everything lah. Okay. Then just use these two cable. This one the A, this one B, this one is the ground. So later this one is to connect directly to the laptop to control using RS485. Okay. Now I just use the PLC to control. So we will be using this keyboard. This one to control.
And we need to use on the system.
Yeah, according to their manual lah. Yes, this one I manually did. So that time last time we buy this one, so I want to check whether the 485 can work or not. I just use there's a software in the laptop can control 485.
This considered as 485.
Yeah, yes. This one is a converter 485 to USB converter. Similar like the one we convert for RS232 to USB converter, right? The 232 to USB converter, the blue color.
This one.
Yes, similar to that concept. But that one is for RS232 to USB.
RS232 to USB.
Yes.
Correct.
This one is the 485 to USB.
485. I remember you showed me that one of the PLC they have RS485.
This one. This the one. This the one.
As long as this, no matter how big it is, this kind of connector considered RS485.
No. No.
For example, this one is not.
We need to know. We need to read from here. Because you see that PLC also, if you go and see, they also have this.
Yeah.
But it's not RS485. It is an analog input.
Here got mentioned.
No. It's from the manual.
So manual, so he mentioned this one is RS.
Yes, because earlier when we buy this one, I thought it's the Ethernet.
Yeah.
So I thought, okay, luckily you can use Ethernet to. And like then only I find out it's the RS485.
Every time I have to check what is the
Yes.
form.
Same thing.
It's not internet, but it's actually different.
See here also. But like Ethernet, right?
Yeah.
You guess what is this? What protocol they using? They just put MJ1, MJ2. They didn't put anything. They just put the name MJ1, MJ2. RS232 communication.
RS232 communications.
That's the
one.
The 9-pin card.
The 9-pin card.
Yes. So they're using the protocol they use is the RS232.
RS232 connect to where?
They have a special cable for this. Yes, but they have a special cable.
Okay, means that in the industry, Google says it's internet. It's not internet, but it has to see the label on
You need to check the manual. That's the way. That's the way.
What?
But-
What is
That one is a printer port. That one is for the communication with the PLC. The old style 9-pin. So let's use this cable. You see, the other side is 9-pin. So the protocol they use is the 232.
RS232.
Yes.
RS232 is the 9-pin.
And normally 9-pin. But in this HMI, they use the RJ45.
This one like converter.
Yes.
And then this one is connect to the PLC. Then connect to the.
No, this one you have to connect to the laptop to download. Because this one now, no USB port. It's an old one, right? No USB port. So they use this one to download the program here.
Then this one had to connect another USB.
That one, yes. Yes.
Wow.
You see here, there's a thing, another thing is. Can you see there's another port here?
Yes.
This is Ethernet.
Ethernet port. Right, so not mentioned.
I'm supposed to mention. Just wait. Because the cover is not this cover. Because this one is supposed to have, must be in on this.
Need to write down.
Yes.
What do you call this?
What do you call the head? That's what the head they call is the RJ45.
RJ? Okay. So now I know now. RJ45 to RS232.
Yeah, but that one, the other side is that they call DB9. Yes. It's a DB9 DB9. Yes. You see this one?
But DB9, they call it DB9, but this one is RS232.
DB9 is the
Connected.
connected name. 232 is the protocol.
Interesting.
It's different things.
Protocol.
So protocol we have Ethernet, RS485, RS232. This one they call DB25. Not 25 pin. The 15 is a DB15, 15 pins.
Projector is a 12 pin.
No, I think it's a 15. Check. But no, projector is different now. They call VIT. So I need to check. So was working very good, but suddenly that day one training cannot communicate. So I just switch. I want to waste time, then I just switch. Good. Good. So many things. Yes. And every day doing this, that's the thing.
It's very interesting. For me, very interesting because you know, if you like, I like that. I like them, but I don't know how to operate.
Yeah. That's the job.
How the communication?
Okay, sometimes you know how it works, but you don't know what is the cycle running right. So sometimes you don't know, you cannot do anything. You know how it works. Okay, of course the robot sending signal to the PLC do the job because inside PLC got program. Okay, what's the PLC done? PLC send back the signal to the robot. Inside robot there's a program. Robot do the job. So two different programs. But how they share data? So we need to know how they share data. So what protocol they use? So now
This one clear.
HMI also we have done, right? HMI the NB panel we done lah, okay. But now when we doing the tenders, we doing the VSFT with the Omron. Then the VTech we will be using with the Mitsubishi. Okay. Then if let's say because you know why? Let's say the Omron I take another 1 day, then Mitsubishi make it 2 days. Is it okay for you?
Mitsubishi cover or not?
No, the same thing. The same thing, but it's another software. That's the thing one. It's another software. So there we don't need to do any logics. I mean like a programming, like a program. So we just need to understand, okay, what is the input, output, how to use the timer, set, reset, the compare, the max function, how there it works, everything. Because the same data type, double integer, real, everything is same. Because they also using D data register for values, everything. But interesting also the Mitsubishi also. But I think 2 days is enough. But you see that
You see,
our
3.5 day maybe another day.
okay, no problem. Because tomorrow what I plan is see the counter lah. Counter is very simple. Counter is similar like timer lah. Timer is you give the input, timer will start to run. Counter is you give the input, it count 1. Again you give another input, count 2, count 3, count 4. Something like that. Okay. Then we will connect that motor. That motor using what? That PLC. Because we must use that PLC, we can't use this PLC. The PLC using Modbus. Then we try to run the motor. Check, I have the manual of the motor. Manual of the motor. Okay, okay, I have some data of the motor. Okay, I think tomorrow we can do the model.
Okay.
I have the manual. Okay, any question?
So far, okay.
So far, okay, and because tomorrow when we do analog most confusing.
Okay.
So before that, make sure you can understand what is integer, double integer, real, the numbers like decimal, hexadecimal, binary. Because that one don't have BCD also, no need to worry about BCD.
The real is what? Okay.
Real is the floating number with the decimal point numbers. It's called real.
Have you checked the protocol system report engine?
No, not yet. Later only I will check. Because you already said they're using the model CC link. So they're using CC link connection.
Yes, it's information. Sharing connection. Let's say there's using six. Okay. One thing is about all these kind of system all pass whatever. Is that we just put in a cable is okay already?
No.
Like for example, you just plug in the cable, you should
Okay.
the program. Of course, you don't like it, then you
Not that easy.
No.
Not that easy.
like this few days I saw you just plug the cable and just how they do
But
the communication.
that one is just normal connection only. Because you are just downloading, uploading. So if you're using Ethernet, then you're using set IP address, you can do. So it's normal Ethernet communication, normal USB communication, normal RS-232 communications. So it's a normal connection. But when you do Modbus, let's say that two a PLC and a motor. So when you want to do Modbus, so the first thing is from the drive, go to the manual. There will be a Modbus setting page. From there, you need to know some data, some address. Like you give me the CC link address, right? Similar to that, the drive will have their own Modbus address. So now, how the PLC want to send value to that address? That is the thing. Okay. So now the PLC want to use Modbus to send the data. Okay. So means Modbus they have their own addressing format. So for that you need to do some programming for that. Then only I can send the value there. So it's CC link. So how the CC link work? Okay, let's say the keyers have CC link. So you go to the keyers software, they will have a configuration. So there you need to add the CC link card module, right? One module. Then from there you get all the data from the PLC. So the idea is like you give me the address of the robot, right? Now my PLC, because PLC address is different one, because the one you give me is the robot address. It's not the same thing with the PLC address. PLC using different type of addressing. So how am I going to send value to that particular address? So I need to do settings. So I need to do additional settings, additional configurations.
Even for the CC link, alright.
CC link, Modbus, Profibus, Profinet, all this. Profibus, Profinet is a Siemens one.
But now I just want to just Modbus and CC link. Okay.
Yeah, Modbus is because Profibus, Profinet is different. It's a Siemens.
We have a CC link here.
No, I don't have a CC, but we can try to do using the Mitsubishi when we're doing Mitsubishi. Because I don't have the device to control CC. Because the PLC can support CC, but I don't have the other device that support the CC. That's the thing. For this one, I have Modbus. Yes, I can do Modbus.
I'm interested to know how the Modbus communication and CC link communication. But the rest of this is just normal communication.
These normal communications.
Yeah, because quite often heard people say when you're using a communication, Modbus or CC link.
That's a common one, Modbus. Modbus is a common one because you know Modbus actually, who developed Modbus? Okay, the first PLC, who developed the first PLC? The first PLC model name is Modicon. That's the first PLC. So then only come out with the Siemens, all these brands. Okay, Siemens, Bradley, Omron, Mitsubishi. Now, why Modbus? Okay, Modbus is like a common protocol. Anybody can use Modbus, something like that. Okay, but they have their own addressing format. They have their own format. Okay, now I am using a Siemens PLC. I'm using a Siemens VFD. So Siemens to Siemens, they have Profinet or Profibus. So just connect the cable, you open the software, so in the software they will have the drive, the configuration. Just pull out the configuration, do a few settings, it can run the motor, no problem. Okay. But now I'm using Siemens, I want to use Omron VFD. Okay. Now this Omron VFD don't support Profibus or Profinet. Okay, so how they want to communicate? Using analog is no problem, just a normal I/O cables, right? But want to communicate how? So now we need to see whether this drive can support Modbus. Okay, this drive can support Modbus. This PLC can send or receive Modbus signal. Yes. Then I connect the cable. I read the manual. Okay, what is the communication setting for this drive? I do the setting in my PLC. Now I need to use their format of addressing to do the project, to do the program. So Modbus is like a common protocol. It's not belong to anyone. It's like a translator. So I send a command to Modbus. Modbus will translate, send a command to drive. So the drive will send a command to Modbus. Modbus translate, send to me.
Omron seldom using the Modbus.
Modbus very common, because you see, I'm using a Siemens PLC. Let's say I want to use Siemens drive, very expensive. So I go with other drive because I just want to control speed and control on off only one.
For Modbus is the built-in with the
All the PLC support most
this
yeah,
also
of course gone.
can.
Can.
I need the cable, right?
Need the connector because this one don't have building, right? So need the connector like the option board.
Oh,
Need the option board. That PLC is a building.
This one?
45.
this one.
Yes, it's already there, right?
485. Ah, yes.
Yeah.
Wi-Fi is only 3 pin only. 3 pin enough. As you see, they have a 4 pin.
Yeah.
Okay, RS Wi-Fi is the Modbus.
No.
No,
485 is a protocol.
protocol.
Okay. So Modbus also is a protocol. So Modbus can be used in two protocols, which is using RS485 also can, Ethernet also can.
Oh, internet.
Also can. TCP.
Protocol.
Yes, they call Modbus TCP. RS485 means they call Modbus RTU. Yes, tomorrow they will be there.
Yeah, TCP, yeah, I heard about name
TCP RTU. Yes. If you use, okay, let's say I have one PLC, one drive. They are communicating using Ethernet.
Yeah.
But let's say, but the PLC don't have the model. The model not support this PLC. So they want to communicate using Modbus. So they want to communicate using Modbus. But the cable, the connection they use is the Ethernet, right? So they call Modbus TCP.
Then let's say Modbus using for the RS Wi-Fi is called Modbus
RTU.
TCP is Modbus.
Modbus using Ethernet. RTU is Modbus using RS485.
This is called RS Wi-Fi, the one is called protocol.
Yes, protocol.
But Modbus is also protocol.
It's a communication.
Modbus is communication.
How we want to communicate. RS485, Ethernet, RS232 is a port. Actually, it's a port. Yeah.
It's a port, right? It's not a protocol.
Yes.
Now I found another question.
Yes.
We have a protocol, we have a connector, we have a communication. Right?
Yes.
Three things.
Yes, what's that?
We have a protocol, connector, and communication.
No
Describe
problem.
the relationship.
Can I erase this?
Yes, please erase.
Okay.
Just about that topic.
So the thing is, there's a lot of things, that's why it will be confusing. Now we have two devices. We have two devices. Huh? Access that device. Huh? Okay. So here they use the
Oh, it's VFD.
variable frequency drive. The drive, the inverter. The inverter we call VFD, variable frequency drive. Okay. This one is the RJ45. It's a port. Okay, RJ45 port. Okay, and the protocol they use, how you send data. Okay, because why I tell protocol? Okay, so we see communication protocols what we have.
Maybe you separate on three things. What you know is your port and then the protocol.
Oh yeah, I know what you mean. I know what you mean. What is RJ45? What is RS45? What is Modbus? Correct. Now, so we see what type of protocol we have. First is RS232 protocols. Okay, RS232 is a one-to-one. PLC, HMI, mostly like this one. Okay. RS485 is PLC connect to VFD. So let's say we have two VFD and just jump with this. Okay. So in this case, they will have an ID number. So this is number 1, this is number 2, this is number 3. Okay. 485 similar to Ethernet. Okay, we call TCP. Okay, which is same thing. PLC, VFD. So they're using a router, connect here, connect here, connect. Okay, good. So this one will have a IP address, right? 192.168.0.1. This one 192.168.0.1. Sorry. 02. This one is 192.168.0.2. Okay, these are protocols. What type of protocol they use? Okay, good. So this one is a port. Okay, this one is a port. Okay, this one DB9 is a port. DB9 is a port. Okay, we call it a port. USB port, serial port. Okay, all that. Okay. So here at the connector, right, the 3 connector, right? Yeah. The blue color. Okay. This one actually is a port. What port actually? It's like just a, we can call as a terminal one. It's a terminal port. Okay. You can call as a, because it can be anything, right? So it's terminal port. Now, so So these are the ports, DB9 or DB25, the terminal port, the RJ45, all that are the ports.
Yes.
Now, what type of protocol they using? Okay, so the DB9 using the RS232 protocol. Commonly DB9, 9 pin. Okay. Then the terminal port commonly is 485. Common. Okay. RJ45 also is a depend. It can be 485, can be Ethernet, can be RS232. Because like I can show you here itself. I can show you. See, this one is the RJ45, correct? But what protocol they using? RS232.
RS232.
Okay. This one also RJ45. Correct. But what protocol they use? RS485. Okay. The connector, the port is RJ45, but the protocol they use the RS485. This PLC also have the RJ45 port. Okay. But what protocol they use?
RJ45 port. RJ45 port.
No, the Ethernet connector. No, the Ethernet. The Ethernet cable. Yeah. That is, the port is what port? It's the RJ45 port.
Okay.
Port. The port is 45. But what communication they using? Ethernet.
Yes.
So now you know the difference between port and protocol.
Okay.
Got it? Huh? Okay. So port is just a connector only. So it can be any protocols you can use. Okay. Now I want to.
But the RJ45 also can be like the internet, right?
That's what I say. The RJ45 is a port. It can be RS232, can be RS485, can be Ethernet. It depends on what the hardware offers you.
Correct.
So like I have the 3 examples. For the HMI, it's using 232. For their drive, it's using 485. But this PLC is using Ethernet. All the 3 ports are the same port, 45.
Okay, same port 45, but in terms of cable out, they still have the connect another connector.
Yes.
RS232, RS
485 or Ethernet.
Internet.
Yes.
End to end is internet. RF.
Yes.
Okay.
Yes. Good example. Okay. If end to end is a RJ45, normally is an Ethernet.
Yes.
If this one is a RJ45, this side is a DB9, it's a 232.
Yes.
If this side is a RJ45, this one is just a 2 cable, it's a 485.
Correct.
Got it?
Yes.
Or sometimes can be a connector also. So we don't know lah. Now, so this one I connect to, let's say this is the VFD, the one I am using. Connect to here. Now, so now I need to send data. So I need to have a communication. So what type of communication I want to use? So now I know I'm using the RS485 protocol. Okay, but what type of communication? Next, the communication is can be Modbus RTU if I'm using 485. If Ethernet to Ethernet, okay, Ethernet to Ethernet cable is an Ethernet, but they use Modbus TCP. Okay, so it means like this. PLC, VFD, so they connect a Ethernet cable. Ethernet cable, but the protocol they use, the communication protocol, okay, TCP. So how they want to communicate? So this is the cable they want to use. What type of cables? Okay, whether they want to use RS232 protocol cable or 485 cables or Ethernet cables. But how both of us want to communicate? So can be Modbus. This is where the Modbus Even the CC link also same. CC link, RTU, CC link, they call Ethernet. Or CC link TCP.
That's all.
Yes. So three things. One is the port, one is the cable. What type of protocol cable you use? Then here. So why I call this as this also is as a protocol. Okay, why? Because if it is 485, then I need to put like an ID. So this PLC will have an ID like okay 2. This VFD will have an ID 3. They call ID or node ID. Okay. But in this case, I will put a IP address. I will using an IP address to talk. So means I use this type of protocol. Means the speed will be higher compared to this. Actually, this one is the old version. Last time they used this one. Nowadays they are using this one, which is the speed is lower compared to this.
So can I say that Modbus CC link is not a cable?
Yes, not a cable.
It's just a protocol.
Yes.
Protocol is we have a port. Usually it's actually the cable connection.
Yes. How you want to connect?
We have a port.
What type of cabling?
What type of cabling?
Yes.
RS2, F5, and the other one is a port RJ45, port DB,
Yes.
DB9.
Yes, good question. Okay. You see, at 232, normally you need 3 cable enough. Okay, 3 cable lah. Normally, if you open the cover and see, normally 3 cable only.
RS232.
Yeah.
2 cable.
3 cable.
3 cable.
Yes.
Okay.
Okay. Then 485 also 3 cable.
Okay.
Transmit, receive 1 signal.
Transfer.
Yes. Receive 1 ground. Same.
Same with RS232.
RS232 same.
Okay.
Then Ethernet, of course, like Ethernet, they will have also same. Transmit, receive, ground, and also the clear everything. They have few more than that. I need to check.
Okay. Cool. Now, totally, because I already think that Modbus, what type of protocol and what kind of device are you using? No.
But there's
I thought, like for example, that CCD, they have a CCD card, and the robot that I showed you just now, it's an additional card on the robot.
Yes.
But they provide the port, they provide a port, depends on the port to connect to the PLC.
yes.
Okay, VFD is an instrument, right?
Yes, it's a instrument.
Okay.
VFD.
How about the robot to the PC not using all this, right? Robot can be the communication to a PLC is through the USB, RS232, all those kind of corners cable to the PLC.
Okay.
Am I right?
Yes.
That one is normal cable just to communicate to the PLC.
Yes, just
to transfer data.
transfer files.
Files.
You mean from the laptop to your PLC?
Yes.
Yeah.
Yeah.
Just to transfer your program, monitor, all that.
Use the USB cable, US RS232. Common one is what cable?
USB, RS232, Ethernet, these 3.
Or this 3G and
These 3 only, yes.
RS232 Ethernet cable, and another one is what?
USB.
USB.
Yes.
Another USB.
That one is to transfer the files.
Okay.
Okay. Then like you said, the VFD is an instrument. The robot is actually also an instrument. Yes.
This is very good actually. This is a very clear picture. Otherwise, what protocol or
Yeah. Because normally I also get RS232 is a protocol, Modbus also is a protocol. So that's why I know very well. When I say both the same name, then you okay. Then what is RS232? That's why okay, maybe I can write something like this. Maybe you can understand.
your writing is very clear, very clear. I like whatever you draw. Yeah, it's very clear. Otherwise, I will think that.
Yeah. That's why I use a lot of this one. Even the slide, the first day you see the slide, right? Before COVID, normally I don't even use a slide also. I like to use this. But during COVID time, what happened is I just did the slide. So I just use back the slide. Because that are the some addressing. Because sometimes the addressing the numbers all you forget. You know what is the CIO number, what is the timer number, all you forget, right?
Correct.
The range. So that's why I created something for all the model. Then I use that. Then the rest, whatever it is the whiteboard.
This is very good. This is the most good.
Yeah, because once you understand this, okay. Let's say you don't know what is Modbus, no problem. Okay, you know, okay, this is how it goes. Later on, you can just work on that. Okay,
Yeah.
go and learn what is Modbus. Tomorrow we do one, so you can get an idea how to do that.
Because so far we haven't touched on more parts.
Yeah, of course.
Because now we only just communicate with the PLC.
Yes.
But in terms of communication with the HMI, will be what protocol usually?
No, normal this one, RS232 or Ethernet.
RS232 or
Okay,
The
why?
port?
Okay,
The port?
good question.
The port?
The port is dependent what type of port. It's the Ethernet, of course, RJ45 port. Normally RS232, normally the round bit. I mean the 9-bit one.
The one being is RS232.
Yeah, RS232. Ethernet they're using the
For the round.
no. The Ethernet they're using the normal the RJ45. Okay, good question. Why the HMI not using this Modbus? Okay, actually HMI also can do one. HMI also can use. Okay, but now in this case, right? I just use the Ethernet, correct? So
Yes.
it's not a what? 485, but it's not a Modbus. I'm not using a Modbus, correct?
Yes, it's not using a
I'm not
it's not
using
using a
anything.
communication.
Okay, it's just a normal Ethernet communication. Okay, why? Okay, you see, when I open the NP Designer, I choose the PLC model, I choose the HMI model because both are there, and I do the communications. Right? Okay, this is my IP address of the PLC. This is the IP address of the HMI. So when I give all the information, the HMI got all the information ready. So he know, okay, now you choose Omron PLC. So when you choose Omron PLC, they have a channel, they have a D data register, they have a W, they have the holding bit, everything. So the HMI already know. So I don't need to do additional program. Okay. Let's say now I'm using the same HMI. I want to connect to Mitsubishi PLC, for example. Let's say in the HMI software, I already select the HMI model, but the PLC model is not there. So what I do? So now, but I need to connect one. That case, now only I will use the Modbus. So now what I do? Okay, I will add a Modbus connection communication. So the HMI know I have a device, but the HMI don't know that is a Mitsubishi.
Okay.
You got the picture?
Another.
So you see, okay, now we talk about the Omron. When you have a Omron HMI, so when you take Omron HMI model, you take Omron PLC model, do the connection. So the Omron know the PLC I'm connecting is the Omron. Okay. Now I select the Omron HMI, then I search. I don't have the Mitsubishi. So what I do, but still I want to connect one. So what I do, I put a Modbus there, Modbus communications. Okay. So the Omron PLC know I have a device, but I don't know what is the device. So what I know is I need to send data to him. He will send me the data to me, but using Modbus. So Modbus, they have their own address. So now when you put a button, it's not the address of the Mitsubishi, it's their Modbus address. So Modbus, they have their own address. For example, okay, 10,000. It means one address, one pin club, for example. Okay. Then in the Mitsubishi, I need to, so when I press the button, must be 10,000. So I send the data. So something like that. So that's why the Modbus is used. So same thing like the Omron PLC. Now in the Omron software, I cannot go and add Allen VFD. If I'm able to add Allen and I'm able to choose, okay, I'm using Ethernet or I'm using the RS232 whatever, then I don't need to do the Modbus, because once I do the settings, the Omron software already know these are the addresses I need to use. So I automatically can use. Since the inside the Omron software I cannot add the VFD, so I need to know, okay, how am I going to communicate? This VFD support Modbus or not? Okay, this VFD can support Modbus. Can this PLC can support Modbus? Yes. Then we talk in Modbus language. So that is the concept.
So unless the instruments, we don't know what is the communication, they only recognize Modbus.
Yes.
So I just create and I buy the Modbus.
Yes.
Modbus is a card.
No. Modbus is a programming only.
Programming only.
Yes, inside the programming.
It's a programming only.
It's a programming. That's why they use Modbus. It's a cheaper. Because this deep programming only.
So Modbus is another software to you?
No, it's not software. It's inside. They have like, you know, the SCL function? SCL, something like a block they have.
Okay.
So you just take the block. Let's say we are doing this one. Just take the block. In the block they will have all the data lah. So you need to tell them, okay, this is the node ID. Node ID is number 3. This is the speed I want to communicate. This is the data I want to send. Then how many data I want to send.
CC-Link also send.
CC-Link also
They're using
same.
a block. Like for example, you block to you.
Yes.
Actually not a physical kind of the hardware. Actually it's not a physical device.
No, actually
It's just a communications, like a block inside the PLC, you just put in the block.
No, CC-Link in different way.
Different.
CC-Link is
Like just now I showed you, they have a CC-Link card.
yeah, CC-Link card is okay. CC-Link card is like a communication. It's like just now I said, I have a PLC. My device is a robot, so I can use because that's the thing. I'm not sure what protocol I use, but what I can imagine is, okay, I have a PLC, I have a robot. Now I want to communicate. I see can use Modbus. Then I see can use CC-Link also. It means I just add the CC-Link. Do you have the project file for the keyens one or not?
No, I don't have.
Okay.
That one is I just only drew the robot as well.
Yes. So what happens is you add the CC-Link card. So in the software you need to tell, okay, this is my PLC, this is the CC-Link card. Add the CC-Link card and connect to this device. So when you connect to this device, you will get all the addresses ready. So no need to do additional Modbus programming. What is in my mind, but I'm not sure how they did. Because maybe when we do the Mitsubishi, right, we can try, but of course we cannot test, but we can try how the CCD works.
I know now. The protocol is only this cable.
Yes.
But in terms of PLC programming, Modbus or Internet, is the programmer inside to do something.
Yes.
Okay. Still the programmer. Still the programmer, not the hardware.
Yeah. Still the program.
Cool. I clear now.
Yes. So some things, you know, we need to add the hardware to understand.
Yeah.
That's the thing. I don't have CCD. I need to buy one any device, a small device in town. Make sure the CCD can work. That's why normally don't have requests, right? So I don't buy. The Modbus all sometimes I get requests on that. So that's why I have one where VFD even drive.
Modbus.
This drive I have 3 pin. Even this one also can use Modbus. You know, this one also, if Can use Modbus also.
Mm.
Means this you just now 15 and 16 go to analog, right? Instead of analog, you connect to that 485. You can get the same temperature. But I need to open the manual and need to read this manual how to get the data. And okay, you see 485 internet is just like okay, now I know I want to use Modbus. Okay, I want to use a Modbus protocol, Modbus communication protocol. But 485 is how you want to do the communications. So using this two cable, right, or using Ethernet. So if I'm using this, the speed, transfer speed is lower than this.
Well, this one is a 2 to 2 and 2 to 3.
Yes.
Like that one.
Yes.
It cannot be just like.
No, it must be from here to here, then from here to here, like jump. Like this because there's a switch. Switch need to use a switch.
Okay, another question is like let's say I'm using this internet to connect both device, two instrument. So in between I also can use a mobile protocol to communicate.
Okay, again, pardon?
Let's say because now I'm using internet TCP
Internet.
to connect both.
Internet. Okay. Internet cable.
Yeah.
Okay.
So as a programmer, I can use mobile protocol.
Yeah. Okay.
Yeah, can right?
Yeah,
Because
okay.
it's just this one below that protocol is just a cable wire.
Yes, cable only. It's just what type of cabling.
One type cabling.
Yes, if you want to use.
In the programming, I can do the mobile.
Yes.
I'm a bit confused. Why need to mention small bus? Because just like normal programming, you send because just only the different cable.
No. No. It is okay. Tomorrow I'll show you because this one I don't have any other hardware, so I can show using Siemens software.
Because I understand now because that's the reason. Okay, why need to mention about bus and CCD? It's just because it's for me not important because as long as I can connect a cable to the device, done. Because that's a protocol already.
Yes.
Am I right? Why did you mention Modbus? Why didn't you mention CCD? They can just make or are using TCP this cable, are using RS485 cable, I say RS232 cable. As long as I know what's a cable, then I can write the program.
No.
No.
Must show what is Modbus. Okay, never mind. Tomorrow I'll get some.
You understand my question, yeah?
Yes.
Because for me, why did you mention about? Because now I clear already. I have a whole picture. Modbus and CCD is just a block inside the program.
Yes, correct.
Then why I have a cable already? I understand my cable connect this RS2. Why I need to mention Modbus? Just tell me what your protocol RS185, RS232, your internet. Yeah.
Then no problem.
You have RJ454, then I can think whether to use the internet to connect or RF485 to connect.
No, never mind. You just make sure you understand until the previous one. This is the cable type. This is the protocol, right? Just stop until that. Tomorrow I show you something, then you can understand better. Why I need this? Why I need this? Because Omron. Because I think I want to show using Siemens. I think, but Omron also got that. That thing is.
How's the RJ45 connect to RJ485 look like?
There's a cable.
This one just now modified, right? Not this one. Not this one.
No,
This
no,
one is
no.
RJ22.
Sorry.
This one, right?
Yeah. RJ45, go to the 2 cable.
Go to the 2 cable.
Yes.
Project
485.
Project 485.
Yeah, the 2 cable. This one is the 485.
Project 485.
Yes. So you see,
No, Project 45.
this one 45. RJ45. Then it's just a terminal. It's a terminal. So you see, got so many 8 pins, right? So when you go to this manual, they will tell you, okay, this pin, so pin number, let's say 5 is the A plus. Pin number 6 is the B minus. From there, okay, I know how to use this. So I just use 2 color.
This connector is RJ 45.
This one is a 485 convert to USB. So normally 485 just terminals.
They have a 4, 5 pin.
No, it's
Not necessary.
not necessary. It's just a pin. That's all.
This connect to the PLC.
No, this one is connected to laptop.
Laptop.
Using the laptop to control this motor. There's a software, there's a Modbus software lah.
Let's say want to connect to PLC, just a pin to connect to PLC.
No, just take out these 2 cable, connect the 2 cable here. Yes. Tomorrow we do that.
Plus and minus only, right?
Yeah, plus minus and the ground lah. To get a smooth.
But you here only
The blue color is the ground. There's a 3 cable, right?
2.
No, the blue color. Additional blue color, yes. That one is a ground. Later I will connect to the motor, the ground.
Okay, clear. Very good, thank you. This is block press 2. Yeah, I received your call. Pukul berapa sampai besok? Kita kalau ya satu saja. Pagi pukul berapa? Sebab I bukan I tak dekat office. Dia memang saya tahu maksud saya semua saya orang dekat sana. Sebab yang address I bagi dulu saya punya office juga lah. Dia operasi kena atau kita operasi saja. Sebab apa tu? Boleh. Lepas tu saya inform saya punya orang dekat sana. Okay, thank you. Go back still doing work also?
No, 2 days.
Now it's time to
Go back. So because I have 1.5-year-old baby.
Yeah, I see quite cute. Yeah. Very cute for your photo, right?
Oh yeah. So baby. Because in my house, myself, my wife, my son are three only, and my brother is staying in working in Singapore. So he will wake up at 5 o'clock, go to work, then come back around 5:30, go makan.
5:30.
No, 5:30.
Oh, so early one.
Yeah, because his working time is 7:30 to 4:30. So because before 5 o'clock he reach the custom, so can come back very fast. Because my house from custom to my house around 15 minutes only.
Lucky.
Yeah. So he will come, then he just makan, then go to sleep. So now my son growing, so need to entertain him.
Oh, yeah.
Now he's starting to talk, right?
Yes.
So I really need to entertain him.
Super.
Good.
Yes.
So there's a fixed training request. Send ready. 41, 14 to 16. Already they have
Okay. Two guys.
Okay, thanks.
Okay.
So they want confirm money to buy PLC. We have already two. One big one, one small one. Just now I check with them. Time PLC they have.
Okay. So okay, boss.
Okay.
See you tomorrow.